Okay, can you guys turn on your webcams, everyone? Everyone. We'll get started. Hello. Okay, cool. Satvika seems to be on the balcony. And yeah, what else? 1 second, wait. There are people joining in. Vivek, yeah, it is necessary. Else you'll be kicked out of the class. Um, okay, nice. Enjoy, Satvika. What else? Everyone, quickly. Webcam. I need to start the class. So Saujanya, you're left. I didn't get that, Vivek. Anyways, today quiz is there. Yeah, you'll have a quiz today at exactly 7 to 7:30. Anywhere during that time, you can answer the quiz. Up to you how you manage it. But somewhere during that time. Saujanya, but you'll have to try to just give it a shot. It works. Yeah, this is where it texts me. 1 second, I'll change my name. Yeah, there you go. That's where it texts me. 7:30, it's lengthy. No. It means that you can answer anytime you want. You can answer chemistry first, math first, whatever you want. But yeah, it's going to be a quiz on complex numbers. So it's on Google Classroom. Shashank, you'll have to turn on a video, and Sai Pratiksha, YouTube. And that goes to Nihad also. Amit too. Yeah, there you go. I don't know that, Sakshi. I'm not sure. Okay, so we'll continue with this. Yeah, so we're discussing different types of numbers and chatting about that. You remember this, right? Yeah. I don't know, Rahul. Yeah, I don't know. Now, with that being said, just need to add a few things. We're talking about counting sheep and all the stuff that is done, dividing land, done. Uh, but here's a few things, few updates. Um, yeah, we stopped here. I discussed this, no solution part. Were we done with this? Can I get a yes or no on that? We're done with that. Yeah. Now, back in the day, so as more numbers got added, more was a discussion. But imagined numbers took longer. In fact, it is said that even this guy avoided imagined numbers. You know this guy? Does anybody know this guy? Did I discuss this guy? Nah. Okay, can you guess? This guy avoided imagined. This guy is like one of the most brilliant mathematicians ever. Yeah, Sakshi got it right. Others? No, not again. 1 second, I missed a lot of your other things, but no. Shashank, we got it right. Guys, we need nicknames for Shashank 1 and 2. Something like that. It's hard for me. Really hard. Murali, you're right. Okay, Sakshi watched the video just now. Nice. Good. The Welch Labs one, right? So you should watch the history part of Welch Labs. That's amazing. So I'm going to do that also. But I think that's one thing people need to understand. So this guy avoided imaginary. Is Euler. Okay, Euler is everywhere almost in mathematics, and he kind of Euler was like, they were known for being a genius. Yeah, touched upon many concepts, and in fact, this guy avoided imaginary. He was like, I don't want to touch them. He would avoid them. Okay, yeah, Euler, yeah. Hey, it's not pronounced Euler. Okay, don't call it that. That's not the pronunciation of it. Anyways, that's a pakka local Indian pronunciation. Yeah. Okay. Anyways, with that being said, there's always this question, and this question was put up in the video, Welch Labs video also. It's like, why do we make students understand something that even the greatest mathematicians could not ever understand? Okay. Um, yeah, he could publish one paper a week. Yeah, it was crazy. I know. Crazy good. Euler was crazy good. But then they say if Euler was in India and was doing research in India, he would not have been that good. Okay, he would have been so stuck with the system that they say that he would have been a terrible mathematician. Okay, the Welch Labs I recommended yesterday, right? You guys watch that. Imagine numbers are real. It's an amazing one. So that video I'm talking about. He had 13 children or so. Nice, good. I don't know if that's true, but I think it's fine. Anyways, brief history. I discussed a few things. Okay, now this is important. What is the solution to this? X is equal to what? You guys know, right? Just tell me the name of the formula. It's a famous formula. For X is equal to what is that? It has a name. Yeah, the quadratic formula. Yeah, okay. Now that's also right. Okay, that's fine. Yeah, a quadratic formula. And you guys know this grand formula which gave us this all this stuff, and it worked. Okay. Now tell me what's the advantage. Yeah, Murali is like annoyed with history. And people are interested in how many wives and children a person has. Where? I don't know. I don't think people bother with that much. People bother with dates when somebody was born and stuff like that, and wars when it happened. For some reason, I don't know. Anyways, listen to this. Okay, so this matters. Okay, this equation matters because if I give you, can you tell me what's the solution to this? When is the solution a real number? You guys have an idea, right? What, I didn't get that. Okay, fine. Medansh fact checks somebody, I don't know, and says he had 6 children. Okay, good. But you get the idea, yeah. When y is equal to 0 or stuff, based on the discriminant. You guys know the discriminant, yes. Now, back in the day, if this came as an imaginary answer, this gave an imagined number, they thought maybe they interpreted this way that graphs do not meet. Is that fine? That was the interpretation. No solution. That was a way of looking at it. Is that fine? This context will be important later. Okay, why I'm telling this. Okay. Yeah. If you got an imagined number here, they just thought maybe if you get negative square root or something, they just like graphs don't meet. That's all. Yeah. Okay. Now here's the thing. Do you see the advantage of having such a formula? Do you guys see the advantage? Okay, I'll give an example. Let me give an equation: x squared plus 2x plus 1 is equal to 0. What's the solution? Tell me. X is equal to what? X is equal to minus 1, right? X is equal to minus 1 is the solution. So this is common sense. This is super easy. You guys know it. But if you plug in here values also for B, A, and C, you'll get the same answer. Is that fine? For anything, it'll work. You could have 2A square plus something. I don't know what not. But it'll work. Is that fine? Got this bit? Can I get a yes or no? Okay. This is common sense now. Now, a fun fact, guys, if somebody gives you a formula like this, and I'll tell you something very important. So one second, is Mithul here? No. Okay, fine. So listen to this. Okay. So listen to this. This will be useful in MCQs, guys. So remember I told you how to rule out options long back. Yeah. If you give you many formulas like this in the options and ask you which of them solves the equation, only try special cases. That's one. Okay, plug in some B, try what happens. What happens when B goes to 0? Try it out. Does it work here? Ax square plus bx plus c is equal to 0. What happens when A goes to 0? Tell me, what's the solution when A goes to 0? If A goes to 0, what happens? Okay, that blows up really, really bad. Okay, if A goes to 0, things blow up really bad. But I think if you leave A becoming 0, 1 second. Make C 0. Make C 0. What will happen? Yeah, A equal to 0 works. This will become Vx plus C is equal to 0. So this should boil down to what? Minus C by B, no matter what, somehow when it changes. So does it work here when you put A is equal to 0? Yeah, it doesn't seem to work, but it actually works. Okay, you just have to rearrange this a little bit. It'll work. Try it out. Give it a shot. It should work. Otherwise, this is wrong. This formula is wrong if it doesn't work when you put A is equal to 0. Okay, just think about it. Figure it out. There is a way. You have to simplify the expression a little bit. Okay. Yeah. No, tomorrow's coding class. We're working on it, so it'll be posted soon. Okay, about it. Keep checking Schoology or Google Classroom for any updates on that. Okay. Yeah. Now, that's one thing. Just keep this at the back of your head that always you can use it. Yeah. If it's not there, also you'll be posted and updated on Schoology or Google Classroom. Both of them. Do not forget that. What's the solution to this, guys? Quickly tell me. Any animation software? Why do you need animation software for that? Now just stick to the concept. I know, Shashank. Doesn't matter. But Python is more powerful, that's why. Okay, so the solution is 3 and 1. Okay, 3 and 1. And 3 and 1. For this, the solution is 3 and 1. You guys know how to solve it. Now, what if I told you I'll pay you $100 for solving this? Is that a big deal? I give you 2 days and I tell you I'm going to pay you $100 if you solve this. Am I stupid? Am I being stupid if I do that? Yeah, right. I'll lose a lot of money. Now, what if I told you, if you don't solve it in 1 day, you have to pay me 100 rupees? Still, would I be stupid with this deal? Yeah. Yeah, first of all, I'm being conjuice. I know $100 is too less. I understand. Let's raise the stakes. Okay. I understand that. So, yeah, I get it. I get it. Now, what about this one? If I ask you to solve it and I give you like 5 minutes and I tell you $50, yeah, good. If you solve it in the next 1 minute, 50 seconds, 5 seconds. Okay, so stuff like that. If I deal with such a game, if we have a challenge, okay, so you get the point, right? You would say this one gives you imagine numbers, this gives you imagine numbers. So you say this doesn't have a solution or something like that. Now, how many of you have heard of this name? It's a popular name, Del Ferro. Okay, this guy pops up, has known for coming up with the solution for this equation. You know, like for example, you saw quadratic equation as a solution, right? Similarly, he came up with a solution for this equation as long as C and D were greater than 0. Is this fine? Got this bit? This is important to the story. Okay, this guy's name. I'll tell you why. He came up with that. Now, what do you think this guy did when he got the solution? The moment he got the solution, what do you think? Do you think he went on jumping around, publishing and stuff like that, telling everyone, look, I've discovered this, I've discovered that? Nah, he didn't run around the streets naked. So here's what happened. What happened was, he was like, those back in the days, mathematicians, whenever they discovered something, they didn't publish it. They made money in a different way. So back in the day, mathematicians made money by challenging other mathematicians. Okay, so why did he challenge? I'll tell you. Now, for example, let's say if I give you an equation, x cubed plus 3x is equal to 4, and I ask you to solve it, how many of you can solve this? No formula, right? Can't solve it. Okay, I challenge you. I'll give you that 1 lakh if you solve it in less than. Nah, I know. I can see the solution myself there. I know the 1 is a solution there. Okay, I'm not stupid. I know 1 is a solution. I'm not going to announce it. Okay, but what if I told you, if I give you something complicated, such as let's say is equal to 5, and I asked you to solve it, and I tell you, if you solve it in 1 week, I will give you, let's just say, 1 lakh bucks. Now tell me, is it a stupid thing to do? To challenge? If I have this formula, if I have a formula for this, is it a stupid thing to do? No. Because other mathematicians don't know, right? No one knows. And that's how mathematicians made money. Yeah, you won't be able to solve it. It's guaranteed that you can't solve this equation almost. Okay, it's almost guaranteed that you won't be able to solve this equation because I know the formula. The formula was complicated, lengthy, but I have the formula. Yeah. So yeah, they wrote letters to great. By the way, when you challenge greatest mathematicians alive. Like you challenged everyone possible. Okay, they made money like crazy. So Del Ferro made a lot of money back in the day. Okay, by having, and this is what the formula looks like. It's a occasionally lengthy formula with the 2 square roots. Okay, it's okay. This was a formula. It is the lengthy derivation. You can get it. Okay, just like this. I'm using Welch Labs itself for this to speak about this. So, or you can check out the Welch Labs thing. So he made a lot of money using this formula. In fact, how many of you think, did you know this? That quadratic formula is so small, right? But a cubic formula like ax cubed plus bx square plus 3x plus, I don't know, cx plus d is equal to 0. This solution to this equation is actually going to fill up the entire screen. It's that lengthy. Okay, x is equal to. And for the quartic equation, quartic, Q-A-R-T-I-C, quartic equation, 4th order, it'll fill the entire, I don't know, entire board, this thing, what is that? 2-3 slides probably, to fill 2-3 slides. And it has been known that the solution for the quintic equation doesn't exist. There is no solution for the quintic equation. Okay, so if you go on in the order of linear equations, quadratic equations, cubic equations, and so on, quintic means to the power 5 for polynomial equating to 0. Turns out there is no, and it was proven. Okay, there's no solution, known solution. There's no way you can even come up with a solution, no matter how hard you try. Okay, for a quintic equation, general quintic equation. So it goes on like that. So just stating something. So, but back in the day, this was the motto, you know, from Batman, right? You might have heard this somewhere. If you're good at something, do not do it for free. So in this case, do not give it away. L'Hopital named the theorem after himself after paying Bernoulli. Okay, okay, nice, nice. Yeah. So, but then Delpher on his deathbed, he gave it to his student Foyer, who was a papa kid, but was like a student. So he's like, let me give it to him, like let him make some money. So on his deathbed, he whispers in the ears of Foyer. But here's the twist. What do you think Foyer did? What do you think Foyer did after he got the solution? Nah, he didn't publish. He also decided to make money. But then he decided money by challenging the greatest mathematician alive, Tartaglia. Okay. Now Tartaglia was awesome. He was very, very smart. Okay. Tartaglia was very smart, and he just threw it in the hands of Tartaglia. And you know what Tartaglia did? Solved it. Tartaglia actually solved it, and Tartaglia got the solution also for the general case. Okay. Now, what do you think Tartaglia did since he had the solution? Now, yeah. So Foyer didn't get any money. Tartaglia solved it, and Foyer lost all his money. But what do you think Tartaglia did? Publish it? Nah, he made more money. Now he made money, but then another mathematician by the name of Cardan comes to him and says, "Bro, you have to tell me. Look, okay, please tell me the solution." He was like, "Don't tell anyone, but only if you keep it a secret." So Cardan comes along and he does it. Now, what do you think Cardan did? Made money or published? Yeah. Cardan, on the other hand, published it. He modified the equation, then he published it. Okay, just like that. Tartaglia was angry, obviously, but then he published it because Tartaglia also could not make money anymore. So Cardan published it, and Cardan complicated the formula for even negative c. He gave the formula for even negative c's. Okay. And I'll tell you something interesting happened after that. Cardan came across this equation. This equation is where imaginary numbers became the biggest thing in mathematics for the first time. Okay. You won't get the formula. I understand. This is, you don't have to know the formula, but the idea is something like this. He was trying to solve this equation. Okay. What about the x squared term? Yeah, there are some complicated things. No x squared term, no x squared terms. This was a simple, this is not a cubic equation. The cubic equation will fill the entire screen. I've told you the formula for the cubic equation will fill the entire screen. It's lengthier than that. Okay. So what he did was he was trying to solve this equation. And then when he was trying to solve this equation, something interesting happened. This came up. Okay. Now, is this good? Nah, what does this mean? If this happens, what does it mean? Tell me. If you get this thing, what does it mean? Tell me. Graphs don't meet, right? It means graphs don't meet. Agree with that? No imaginary numbers back in the day. Graphs do not meet. That's the logic. Yeah. So, but then if you observe carefully, I don't know how many of you see this. This one has a solution. Can you see that? I don't know whether you're looking at it carefully. See, usually back in the day, if something imaginary came, they were like graphs don't meet. But observe this, something interesting. If you got something complicated, they were like graphs don't meet. They don't meet at all. But x is equal to 4 is a solution, guys. Yeah. X is equal to 4 is a solution to this equation. Graphs do meet. And in fact, it meets the graph 3 times. And if you don't believe me, watch this. It meets the graph roughly 3 times. I'm not kidding. So you can't simply ignore it. You simply can't ignore it. This is what the plot looks like. 1 second. How do you ignore it now? Tell me. The graph meets the thing 3 times. X is equal to 4 and x is equal to minus 2.08 and also meets at minus 3.72. So now tell me, how do you interpret this? It does meet it. All its solutions are real. None of them are imaginary. Got the logic now? Why this problem was such a game changer? Okay, it was a game changer for a reason. This problem was a game changer because for the first time they realized this when this popped up, they could not throw it away anymore. How did he get? By solving, by simplifying it. if you plug in the values, you'll get it. That's the idea. But ultimately, when he plugged in, he got it. But the fun part is, see, if you asked Tartaglia, he was like, this is impossible. And if you asked, what do you say, Del Ferro, he would have said, nah, it's... So Cardan, what he did, he threw it away. Cardan was like, maybe this doesn't make sense. This is just some sort of stupid thing. He's like, it's not possible. But then there was a guy named Bombelli. Okay. Now this guy is important to the story. Very, very important. Weird name. I get that. But listen, okay. So Bombelli was important to the story because Bombelli was like, maybe we could deal with it. You know, we could do something with this. We could play the game. Yeah, you might know about this. This was in Welch Labs. Yeah. So he was like, let's make this new number, follow some algebra. Let's treat it like, give it the respect that it deserves. Okay. Let's give it the respect. No, that's, it depends on the Konkani actually, but yeah. Anyways, so they were like, okay. So let's just use some algebra. For example, what does this give you? Tell me. You guys know this, right? What does this give you? Come on. Root 6, right? This is root 6 in common sense. You guys know that. Now, they was like, let's play the game same way. For example, what is this? You know, you can factorize as root 2 into root 7. So he was like, let's play the same game. Similarly, what about this? He was like, let's use it the same way. Minus 16, root of minus 16. So he was like, let's factor it out this way and keep it as it is and call it 4i, 4 times square root of minus 1. Is this fine? He was like, let's respect it like regular numbers. Let's deal with it like regular numbers. Okay, hope that's fine. Now, what happened next was, so he was like, every negative square root of any number can be expressed this way, almost. Any number out there, square root of any negative number can be expressed this way. I know the slideshow is getting stuck, I heard. Is it? One second. I'll come to that. Shashank, I'll come to that. So this is how they treated it. They were like, this is positive number and stuff like that. Okay. Next part, you know what is this, right? Together gives you 6x. So I know you take it for granted today that 2x plus 4x is 6x. But then he was like, let's treat these numbers also same way. Give it the respect of x. Okay, make it 6 square root of 1. Now for you, it might be common sense. For you now, it might be common sense. Yeah, I know. One second. Can you guys see the slide now? I'm sorry if there's a PPT lag. This is weird if there's a lag. I think I know the reason why it's happening. So give me a moment. I'll switch to a different internet. So that's one thing. Next part, what about this? Tell me, what is the answer for this? So tell me the solution to this. Quickly, like solve this one. Yeah, tell me. Some of you are wrong, some of you are right. Let's see. Keithan, you're right. Keithan, you're right. Then I don't know. One second. Keithan is right. I think so. Wait. Yeah. Keithan is right. Sakshi is right. Shashank is right. So there's something interesting you need to know here. But when he tried using these methods, one second. I'll just try to switch to a different internet. V. Shashank, V is correct. Okay. I think now internet is faster and better. Okay. Now, something you must be careful about. This is what you guys did. But you guys are wrong maybe. But here's the interesting thing. That is, this is wrong. Okay. This is totally wrong. Okay. If you did this, there was one problem though. This is where things went wrong. Okay. This is the only place where you'll go wrong. But for now, you can treat it normally. Okay. And I'll tell you why it goes wrong in some time. This is a proper way of doing it. You multiply 5 into square root of minus 1, 2 into square root of, 2 into minus 1, and then do the splitting. That changes everything because this becomes root 5 into root this thing, which gives you how much? Minus root 10. Is this fine? Got this bit? This makes a difference. I'll tell you why. I'll tell you why it's minus root 10 and not root 10. Okay. I'll explain why. Okay, listen to this bit. Some of you might know this. Can you tell me why it's minus root 10? The only simple case we have to be careful about is this one. Okay, I'll tell you why. I'll tell you why. Listen to this carefully. Okay. Uh, yeah, 1 second. Trying. No, no. The reason is it leads to a problem. What is -1? Do you agree it's square root of, sorry, -1 is nothing but I square. Agree with this? Can I get a yes on that? Yeah, you can treat it that way, but hope you agree with this, I square. But what is square root of square root of -1 here? This is square root of -1 into square root of -1. Agree with this? Can I get yes on this? Yeah, this is I square, so that gives you that. But this can be written as square root of -1 into -1. Is this fine? Which is nothing but square root of 1, right? But that is 1. So I've just proved you -1 is equal to 1. Something went wrong somewhere. Along this line of reasoning, everything that I've written, something has gone wrong. Can you tell me, pinpoint the exact step where things went wrong? Everything was fine, but there was one step where everything went wrong. Some say that it's this step, -1 into -1 is 1. Okay. I'll number the steps. This is step number 1, step number 2, step number 3, and step number 4, and step number 5. All these steps. Where things went wrong? Where do you think things went wrong? Okay, okay. Some of you think it's 5 because this can be plus or -1, right? Answer can be plus or -1. Okay, some say it's step number 2. Why? Okay, 2 seems normal. I'm just writing I into I. This is I into I. Okay, I'll tell you where things went wrong. It's actually at 3. Things went wrong at 3. Terribly went wrong at 3. Yeah, terribly things went wrong at 3 because this, if you have two negative numbers, this is not true. Always remember this. If you have two negative numbers, then it's not true. Okay, that's why same thing happened here. This rule that you had studied doesn't work for two negative numbers. You can't simply do it. Got the logic? I know most of you told it, but got the logic? It doesn't work for two negative this thing. If one is a negative number, one is a positive number, that will work. Like 5 and -1. Okay, is that fine? Yeah. So 1 second, I'll just. Things go wrong whenever there's a negative. Okay, things go wrong when you have two negative numbers and you're trying to apply. How root of -1? I is defined as root of -1. I is square root of -1. I is -1 is nothing but I into I square. But I is root of -1 into root of -1. I is nothing but root of -1, right? Yeah. Now, with that being said, so that was the only twerk, only thing where things could go wrong. But if you eliminated all those weird possibilities, when you simplified this expression, finally it just boiled down 2 plus I and 2 minus I. But what is 2 plus I and 2 minus I? Sum together. 4, right? Agree with that? Yeah, when he applied those tricks and he simplified it, he just got 4. Proving that it works. It works. Okay? If you give the respect that, what is it, treat I like a number, treat square root of -1 like a number and give it that respect, they started realizing that you could solve mathematical problems finally. Okay? So this happened, and for the first time, mathematicians could not simply throw away complex, imagined numbers. They couldn't throw them away just like that. Okay, but then Bombelli just thought it was a hack. Okay, he just thought it was a trick that he had used, and again, it would raise questions such as what is the area of -1 mean, and what is the side of a square with the area of -1 even mean? You know, he thought it was just a hack. Now, I'll tell you why this mattered, that we called it a hack, because if he had called them like, if he had, treated them like normal numbers and gone on and published it and made a big deal out of it, today we would have been calling complex numbers as Bombelli numbers. Okay, which I think is not a great name for a number, personally. Okay, yeah, we would have landed up calling them Bombelli numbers. So I think it's fine. Imaginary number is worse. The term imaginary is worse, but Bombelli sounds even worse from that. Okay. Gauss called them lateral numbers. Gauss called them lateral numbers. Gauss called them lateral numbers. Lateral because they're above the axis. They lie above the axis. Okay, he called them lateral because of that. So there are different names, but okay. Now the important part. What's the difference between a complex number and imaginary number? Can anyone tell me? Sounds like a Mangalore bus city. Okay, Mangalore city bus stop. It sounds Bombay. Nice. Sounds like that. I get it. Come on, guys. They don't meet in the z-axis. They don't meet in the z-axis. I didn't say they meet in the z-axis. They meet somewhere. They'll come to that. What is complex number and imaginary? What's the difference? Is there a difference or are they the same? Yeah, Medan's got it right. Complex number, they're different. Complex number has two parts, one a real part and an imaginary part. Okay, they involve both. It's a sum of a real part and a complex part. Is that fine? Yeah, I saw that, Anika. Yeah, is it fine, guys? Just received it now. Okay, that's the idea. That's the basic idea. Now, for example, this is a complex number with only imaginary part. It doesn't have this thing. Real part is 0, so that's 4i. Similarly, this is I is just an imaginary number because it doesn't have a real part. So complex number with only imaginary part is imaginary number. A real number is something that has no this thing. A combination of both gives you a general number called complex number. It's much more bigger. So all real numbers are complex numbers. Yes, all real numbers out there are complex numbers. Do not forget that. Okay, similarly, all imaginary numbers are complex numbers. Okay, and complex numbers is this biggest set out there, which completes everything, which has everything in it. Okay, is everything clear so far about the basics of it? This is important. Yeah. Now, all complex numbers are real numbers. You can write any. Look. What about this? 2 plus 0i. Is this a complex number? Two plus 0i. This is a real number, right? But it's also a complex number. Look, the complex number form is 2 plus 0i. Oh, by the way, 0. 0 can be written as from now on 0 plus 0i. Do not forget that. It's no longer 0. Okay, in the simplest sense anymore, at least. Okay, so even 0 is a complex number. Everything is a complex number, ultimately. In fact, you can think of any number you have thought of so far or almost all complex numbers. Yeah. So hope that clarifies things, the basics of it. Yeah, good. Now, so the question is now where to put them on the number line. 1 second. Real numbers are a subset of, yes. So all real numbers are complex, but not all complex numbers are real numbers. Yes. Complex number set is much bigger. Okay, complex number set is much bigger. Yeah, 1 second. Things are going to get better already. 1 second. Okay. Now the question is, we respected so far we did the puja, right? We respected the imaginary number. We brought some rules. Everything is fine. Now we have to give it the respect by putting it on the number line. If you invent a new number, please put it on the number line. The question is where to put it on the number line. You can make a separate number line. That's possible, but the question is where to put them. Yeah, Vivek is like he doesn't care. This guy sounds like a engineer for some reason. Okay, for some reason he sounds like an engineer right now. Okay, yeah. And by the way, that's not good. Okay, when I call somebody engineer, it means it's horrible to call someone an engineer. Okay, it's out of full. We treat engineers like, what do you say, kids. They're like what do you say. What is it? Physicists always treat engineers like I don't know, not like kids. It's like they're like slaves for us. Okay, yeah. Oh no, I'm not an engineer. I'm technically a physicist. Okay, technically, so that's why. Yeah, it's inferior. That's all. Anyways, so yeah, engineers wouldn't exist if there were no natural numbers. Anyways, they're like, yeah, I know. Anyways, mathematicians keep roasting physicists and physicists keep roasting chemists and engineers at the end of the day. Anyways, with that being said, so the question is where to put things on the number line. Okay, like where to put them on the number line. Now, here's the thing. One possibility is search for patterns. We'll search for patterns now. This is a game of finding patterns. Okay. Uh, First of all, what happens when you do, I don't know, 2 to the power 1? What is 2 to the power 1? Tell me. 2. We'll play a game. We'll go on quickly. Can real numbers be part of imaginary? Real numbers be part of imaginary part? So here's the thing. The definition of a complex number is a plus ib, where a and b are real numbers. Okay, got this, right? That's what we say. So for example, this could be imaginary number 2i, but this 2 is a real number. Okay, so the pattern you guys know, right? Patterns, you guys go on pattern. Let's see how long you can keep this up. 2 square, quickly. You guys need to know this. If you want to get into computer science, this is a must. 2 cube, 8. 2 to the power 4, power 5, 2 to the power 6, 2 to the power 7, 2 to the power 7, 2 to the power 8, 2 to the power 9, yeah, 2 to the power 10, 2 to the power 11. 11 is important. 10 is 1000 is saying 2048. 2 to the power 12. 4096. Good. 4096. Yeah. 2 to the power 13. 8192. Okay. It goes on like that, but you guys need to go on like this. Okay. Up till 16, if you go, I think 65,000 something you get. Yeah. You remember the story of the beggar who asked for rice, right? Remember that? I told you. Beggar who asked for rice, one rice on, yeah, on everything. Yeah. It will go on doubling. Yeah, if you play at 2048, you know this. Okay, the game 2048. Yeah, but here's the important part. It goes on blowing up. But see, if you try to interpret patterns, you will get some idea. What about 2 by 0? What is 2 by 0? Yeah, most of you will say infinity. By the way, fun fact, what is basically, I know, Murali. But what is basically division? What is division? What is division at the end of the day? What does it mean when you divide 12 by 4? It's repeated subtraction, right? It's about counting how many times do I have to go on subtracting 4 from 12 till I get 0. Once, done. I don't know, 8 minus 4 again gives me 4. And again I ask 4 minus 4. Oh, it happened 3 times. So I'll say, okay, 3 times. So the answer is 3. It's about continued subtraction at the end of the day. But what the question is, when you try doing it with 0, it goes on forever. You'll never reach 0. So you call it infinity and say it's a very big number and stuff like that. It's an impossibility. Yeah, maybe you could think about it that way. But the idea is, whatever remains at the end of this subtraction is called a remainder, whatever. Okay. But the idea is, you can interpret division as subtraction, and that can give you some insights, right? Similarly, what about this one? Quickly tell me. I to the power 1 is I. But what is I square? You guys know this. Most of you know this. Hey, you won't get a number. It will go on forever. This is minus 1. What is I cube? I cube is I square into I, right? But what is I square? I square is minus 1 into I. So what does it give you? Minus I. Is that fine? Got this bit? I cube is minus I. I square into I, but I square is minus 1. So minus 1 into I is minus I. Can I get a yes on this? Clear? Yeah? Please make sure you guys know this. Okay. Next question is, what is I to the power 4? That is nothing but I cube into I, which is nothing but, I cube is nothing but minus I into I, which gives you what? Some of you guys are right. 1. Is it fine? It's 1. Or it's I square into I square. Minus 1 into minus 1, which gives you 1. Is this fine? Got this bit? Can I get a yes or no? Clear with this? Yeah, okay. What is I to the power 5 then? Yeah, what is I to the power 5? This is minus I, done. Then this is 1. This is I. What is I power 6 then? Minus 1. It goes on like this. Yeah, I'll come to that, Shashank. Why? It's not taken as plus or minus 1. I'll come to that. Okay, that I'm still long way from that, discussing that. Okay. But this will be nothing but minus I again, and this becomes 1. So do you see the repeating pattern, right? You see the repetition, right? It goes on like this. I power 9 is I again. Yeah. So this gives us a hint of where to put it on the number line. Some hint. So mathematicians start playing a game like this. They were like, we'll start interpreting them. So first things first. I think I told you this, right? We choose numbers depending on the problem. Agree with that? I remember the question we had. We were discussing about Nidhi's uh, number of children Nidhi will have long back. Where's Nidhi? Yeah, she's shying. Now, anyways, just kidding. Okay, so we're caring about that. So you choose whole numbers if you're discussing about Nidhi's children and you want to figure that part out. Okay, yeah. Anyways, but if you get 2.5 as the answer at some point, okay, if you would get 2.5 as the answer, wouldn't it be strange? It'll be strange, but then you know that you took whole numbers, which means it tells us impossible. The problem doesn't have a solution given the constraints. Maybe we described too much about Nidhi and stuff like that, and the problem was like, nah, no answer. Okay, for the given situation. It didn't say 0 kids. It told given the situation will not occur. Okay, fine with that. Now, what if someday, if you want to get somebody's bank account number, what number would you use? Real numbers make sense? Yeah, that was 2.5 men. I know. Yeah. So the idea is that you'd use real numbers, and that makes sense. Usually, bank account. If you're, but one day, let's say Jason wakes up and he finds out that his bank account looks negative numbers. It's fine, right? In a bank account, it's fine, right? It means debt, under some debt or something. It's fine. You're solving the problem that can be positive. But what if Jason wakes up in the morning and he observes that his what they say bank account is this? Now, should he flip out? Yeah, that is stupid, right? Whatever it is, that's stupid. It doesn't make sense. That's going to be his reaction, whatever it is. Okay, like what? What is this? Okay, so we know that it's impossible. So depending on the problem, we choose numbers. Okay, if you're trying to find the electron in an atom, use complex numbers. Works. These numbers really work for atoms. Okay, it doesn't mean there has to be some meaning to it. It's just the math of quantum mechanics is so well works with what do you say complex numbers that we start using it. It just happens. If you're trying to use it, complex numbers make sense. So in quantum mechanics, we use complex numbers. How? I can't come to that. It's a deep, I don't know, 2 year journey in quantum mechanics. Okay, to understand that, I can't give it to you now. Okay. Yeah, he has imaginary money or something. No, imaginary money. Don't interpret imaginary numbers as okay. By the way, this doesn't mean that he has imaginary money. It just means that the problem that you've given, problem we're trying to solve, given the situation, there's no solution. Okay, fine. Just saying. Yeah. It's a template. Now, for example, have you solved simultaneous equations, guys? Simultaneous equations. Yeah. For simultaneous equations, what do you think are the best numbers out there that work really well to use? Have you heard of something called matrices? Now, you guys have never used matrices to solve these things, okay? But there is a method where you use numbers called matrices. They work really well, okay? They solve simultaneous equations faster than what techniques you have learned, okay? So my point is, we use numbers depending on the problem at the end of the day, okay? That's the gist of it. So we choose the numbers depending on the problem. Now, then once we have the numbers, uh, no, Kramer's rule is not great, Shashank. It's horrible. I'll tell you, it's horrible. You'll realize. Okay, someday. It's for engineers. We mathematicians created Kramer's rule to solve simultaneous equations for kids. Okay, and there is a reason. Okay, why it what you say works faster and stuff like that. But then it doesn't work always. Okay, yeah. Now, so once we have the numbers, we give them an algebra. We give them a structure. We tell them you add these two things. This is what you get and stuff like that. We give it some structure. Okay. Now I'm going to do a big transition here. This idea is super complicated, but I need to put it in your head right now. Now, this is an idea. If you put it in your head right now, whole of second PUC and first PUC mathematics starts to make sense finally. Okay. This is an idea. This is a transition that has to occur at least at the age of your age. Okay. I know this is too early for you guys, but it should happen at least at the first PUC age of first PUC. Okay. That numbers can behave like actions. Okay. Now you might ask, how is it possible? Okay, this I'm picking up from 3 Blue Unruns video on group theory, introductory group theory. Now there's a chapter called group theory, a very complicated topic in mathematics, but it's a beautiful one. It finally answers the questions such as why -1 into -1 is +1. Do you guys know why is it so? You don't know, right? But the answer lies in group theory, a topic called group theory. Why is that? Okay. Yeah, now we really get why mathematics is root physics. We deserve it. Okay. Anyways, we roast them too, so it's fine. But the idea is you guys took it for granted, right? That minus into minus is plus. Yeah. Shashank is like minus and minus gets cancelled. I don't know. But there are serious reasons, guys, why those things were created. Okay. Group theory answers those questions. So I'm going to do introductory group theory here, but in the most simpler sense. I won't give you the whole picture of it, but I need it. Okay. Numbers can behave like actions when you associate them with an operator, like multiplication. Like for example, if I give you a number itself is not an action. But if I give you a number such as +3, this is an action now. Do you agree with that? Like for example, if I take an object called 5 and perform the action +3, what will I get? Yeah, into will be doubling and stuff like that. Yes, action in the sense number +3 acts like an action. It gives me 8. Now again, if I perform the action +3, what will I get? What's the user if not for, I didn't get that, I missed that. Okay, 11. So you see that, right? So basically, if you are on the number line and only action in the world is this one, you see you will jump from wherever you are. Let's say you're at 5, you'll jump to 8. If you're at 8, you'll jump to 11. So numbers can behave like actions in some sense. This action might be pointless and not so useful, but at the end of the day, it's an action. Similarly, multiplying by 2, as Nidhi said, is doubling action. It doubles everything, depending on where you start. Is this fine, guys? Got this bit? Numbers behaving like actions. Add 3 is an action. Okay, add 3 is an action. Okay. With that being said, actions can change objects. This is important. Like for example, you started with 5, but you ended up with a new object, that is 8. Is this fine? Under the action of +3. Does that make sense? Got this bit? It's an action you're performing. It's in the simplest English, what action means is action. Okay, I can't explain what is action. Okay, there is a physics quantity called action, like momentum. That's a different one. Okay, that's completely different. That is defined. Okay. Yeah. Anyways, okay. So with that being said, actions can change geometric objects too. For example, if you have a circle, and if I perform an action like flatten, I don't know, some action like rotate by the center by 30 degrees, what do you get? That's an action. A circle, right? Again. Similarly, if I take a triangle and I rotate by, let's say, 60 degrees, what will I get? A new object, right? Something like this. Now you're getting it. This action is much more general. This concept of an action is much more general. It's used, in fact, the whole geometry that you did so far, entire geometry that you did in your entire life was basically basic group theory. You were doing some rotations, transformations, translations, and not whatnot. Okay, without your knowledge. You were rotating a figure and stuff like that. So all of this comes under one topic called group theory, which captures most of the mathematics out there, whatever you have learned so far. Okay, so entire geometry is actions on yeah yeah Nidhi, good for you. That's the thing. So action on geometrical geometrical figures is geometry. Action on numbers is arithmetic. Action on alphabets is algebra, what you studied. So ultimately everything is captured in one topic here. Okay. Yeah, I understand. So yeah, basically, by the way, there's an entire book. See, I don't know if Srikanth does geometry, if Srikanth teaches you geometry at some point, he will not teach you in the general NCERT textbook sense. He will start teaching you first what is translations, what are actions, what is symmetry, and then he starts geometry. Okay. In fact, even Winton is now following the same approach for geometry. So this is a different way of looking at things once you understand actions. Okay. Anyways, Oh, Srikanth is one of the professors at the PU, and he works at TIFR. Um, TIFR, the same. ICTS, International Center for Theoretical Sciences, Bangalore. So he keeps taking up classes occasionally. Any book on group theory, or there is a book on theory. There is a book on group theory which you guys can understand too. And by the way, group theory also answers the question why quintic equation does not have a solution and stuff like that. Group theory is the reason gives you the answer. Okay, why you can't derive an equation for quintic quintic equations. The book is called Visual Group Theory. It's a book with zero equations, less equations, as many less equations as possible, but only diagrams. It's called visually. Fine, Murali. Visual group theory. Sorry, not visually. Visual group theory. The book is called Visual Group Theory. Nathan Carter. This is a book I want you to read with a little bit of cautiousness, but yeah. Yeah. Even in Sakshi says even in calculators you can't find to the power 5 equations. Yeah, same reason. There is no solution. There is no general solution. There are methods, but you won't have a general formula. There's no general formula. In fact, even the quartic equation to the power 4 equations, the solution in a calculator will take very long. Like it'll take forever almost, because the formula for that is almost covers an entire page. I can show it to you. It's on Wikipedia. Search for it, you'll find it. The formula exists for a quartic equation, and it's annoyingly lengthy. Okay, anyways, that's the thing. By the way, one fun fact, this group theory comes in chemistry also. Have you heard of isomers? Yeah, at the end of the day, they're basically actions performed on chemical compounds, and they remain the same and stuff like that. So ultimately it boils down to that. Yeah. Okay, fine, Murali. Anyways, so mathematicians asked some questions. They were like, what happens when I multiply, when I perform the action, if I take a number line, and if I keep 1 here, 0, 1, 2 and all, if I'm at 1 and if I perform the action -1, multiply by -1, where will I go? Yeah, I know, Shashank. Where will I go? I'll go to -1. Agree with that when I perform the action. Again, if I perform this, I know I'll go here. So if I'm at 2, where will I go? I'll go to -2. Under the action, multiplication by -1. Okay, mathematicians were like, look, it seems like I'm getting flipped. Wherever here I am, I'm getting mirror imaged along 0. Is that fine? It feels like I'm getting mirror imaged along 0. Wherever I'm, if I'm at -3, I'll go to 3. But mathematicians are like, don't think of it as a flip. Think of it as some form of rotation. Do you see number 1 is getting rotated? Feels like it's getting rotated and going back. You can interpret it that way also, right? If you interpret it that way, and if you try interpreting it that way, what is basically multiplication by -1? Do you agree it's... I know. This is not pure math. This is playing playing the cards, whatever you can think of. So they were like, what if we multiply it 2 times? Do you see I can break down multiplication by -1 into 2 square roots of -1s? Is that fine? It's I square, right? Agree with this? So they were like, what if when I multiply, okay, my number line has been shifted due to some technical issues, but bear with me on that. Okay, so the 0 is here, this is 0. The big combo is there, right? That's 0. Okay, yeah. Anyways, with that being said, going ahead, they were like, if I multiply by I, then don't you think it makes sense that maybe multiplication by just performing half the action, I go here, and this is the reason why this is where I is. Well, maybe that's where I is. It feels like intuitive. I can put an I there. Okay. Yeah, Shashank, thank you. Yeah. How many of you are checking WhatsApp group 9? Seriously? Okay, just kidding. Now, anyways, with that being said, hope you guys got this logic. That goes to I. Okay. Yeah. Murali, how is it that you guys are sending some messages right now to me, all of you at a sudden moment, sending same messages, same type of messages? Why is that? Murali, why is that? Why am I getting a stream of similar messages? if you guys don't know what's happening. There seems to be probably a Zoom group. Okay, there's a Zoom group. Okay, fine. Anyways, it's coming from a Zoom group. Anyways, yeah, you guys have been fools then. Okay, fine. Anyways, so anyways, with that being said, the idea is that if you stay at 1 and if I perform the action multiply by -1, it feels like a rotation of 180 degrees. So they were like, what if just performing half the action, only multiplication by root of -1, just takes me up there, a rotation by 90 degrees. If that's the case, doesn't it feel like -1 into, when I take 1 and I perform the action multiply by I get I, right? Agree with that? I take 1 and perform the action multiply by root of -1, I get I. So this must be the location of I. One way of looking at it. Okay. Yeah, Murali, yes. Okay, the idea is, see, performing half the action is like a rotation by 90 degrees. So they were like, what if it's 90 degrees and 90 degrees? Okay, 90 degrees and 90 degrees, the rotations. Yeah, Ratisha. Yeah. So 90 degree rotation. Okay. Now, total rotation is 180 degrees. So they were like, maybe when I perform the action to 1 of multiplying by root of -1, I get I. So like, maybe this is the location of the imagined number. Is this fine? Kinda, can I get a yes or no? Yeah, Shashank, that's true. Okay. Kuch bhi, I know. If you're a pakka pure mathematician looking at this, you have to go kuch bhi. I know. One second. This is one way of looking at things. Okay. Anyways, with that being said, listen to this part. Okay. So we get to this point now. One second. So consider this. No, what I'm trying to say is, if you take 1 and perform the action into root of -1 and again into root of -1, I know I'll land up here at 1, at -1. But they were like, I'll just perform half the action. See where I land. If you perform just half the action, I'll get 1 into root of -1, which is I. So they were like, maybe if I perform half the action, I must land here. Okay, yeah. Now, based on that, what happens if I again multiply by -5? Where will I go? I tell you, this idea is very important. This critical idea of rotations is super important. Yeah. I'll come to that. That's the reason, Shashank. Again, I will get rotated by how much? Tell me. This might seem like jargon and stupidity, but it works. Watch this. What do you get? Tell me when you multiply by I. Yeah, this number line has an issue, guys. It has some dyslexic problems. I'm sorry. It gets shifted to the right. I'm sorry. PowerPoint issues. But you know I get -I, right? So they were like, maybe this is the location of -I. Okay. What if I perform the action again? If I take -I and multiply by I, I'll go to 1, right? Agree with that? Yeah. They generated that. Yes. So they generated that. Is this fine? Getting this part? Kinda. It seems like as if, performing this action continuously gives us back 1. I know. This is 0, by the way, just saying. Look, I have to murder a bunch of numbers, guys. This is bad. Oh, God. This is so cruel. One second. Imagine only the numbers at the top: 0, 1, 2, 3, 4, 5. And this is -1, -2, -3, -4. Is this fine now? Make sense? Yeah. Does this make sense now? If the diagram was misleading, sorry. You go from 1 to I. If you perform the action again, you go to -1. If you perform the action again, you go to -I. Perform the action again, and you come back to 1. Is this fine? Sumit is like, phi is not equidistant. I'm sorry for my Picasso-like skills. Okay, if I can't space phi properly. Okay, but anyways. Okay, with that being said, they were like, maybe now. Okay, I'm not done. What if I perform the action 2? For that I multiply by -1. What do I get? -2, right? So I now go here. I go here. Oh my God, that's not a arc in any way. That's an insult to all the arcs around the world. Okay, some achievement. Is that fine? They were like, so this multiplication by -1 does that. So they're like, what if I perform the action only once, half the action? It should go somewhere up here, right? Agree with that? But what is 2 into root of -1? Tell me. What is 2 into root of -1? 2i, right? So this must be the location of 2i. So basically, if you go on doing this, all this stuff, you'll see, you'll go on interpreting this, you start realizing you can fill up an entire row of dead numbers. 1 second. 0, 1, 2, 3, 4, 5, -1, -2, -3. I hate PowerPoint for this part now. Okay. Anyways, if you see it, you will go on filling up locations of these numbers. Got this part? Yeah, sure, Medan, sure. Is this fine? This is not the y-axis, guys. This is not the y-axis. I'm telling you now. That's the reason I'm telling you. This is not y-axis. It's not the y-axis. It's a new axis with imaginary numbers on it, called the imaginary axis. Is this fine? Getting this bit? Yeah, yeah. Hell, yeah. I get it. I get Murali. So. Yeah, you can interpret it that way, Shashank. Why minus into minus is that way. Pratisha, okay, cool, calm down. Okay. Now, with that being said, now, so the question is, they were like, if this is possible, now I can play around some games, right? I have something like a coordinate system now. So I can represent almost every number I can think of, complex number. They were like, look at this. If I want to represent 1 plus I, what is it? Tell me. 1 plus I, complex number 1 plus I. Do you agree this will be that point? I. Similarly, what about 2 plus I? 2 plus I will be here. This point here, 2 plus I. Yeah, fine, Pratyusha. 2 plus I. Is that fine? Got this logic? So I can represent almost everything. It's like a coordinate system, but it's not the coordinate system. It's a complex plane. Okay, why we are calling it a complex plane? Remember, real numbers were on a line. Real numbers were on a line. Now the numbers are on a plane. It's a full bunch of numbers standing on a plane, sitting on a plane. Not standing, sitting, doesn't matter. On a plane. Is this fine? It's called the, yeah, it has a name. It's called Argand plane or arrogant plane or whatever you want to call it. Okay. But just don't ruin it though. Okay. Anyways, that's the name. It's called complex plane. Okay, I prefer that name. Okay. Anyways, it's called the complex plane. Now, the complex plane is basically tells us that all the numbers. No. It's not 2 into I. It's 2 plus I. This point is 2 plus I. So they were like, we can label any point we want. Like this will be nothing but 2 plus 2i. This point here. This point here will be 3 plus 3i here. Okay. I can't show you how, but okay, I'll show you 2 plus I. On demand numbers, guys. 2 plus I. Done. Marked. 2 plus I. You guys throw me the complex numbers, I'll mark them. That's a new sport here now. Tell me, quickly. Throw me some numbers, complex numbers. Which are within the bounds of this sheet? Which are within the bounds of the sheet? Already numbers started coming in. Okay. Sakshi, good. 3 minus I. 1 second. Be like Sakshi, guys. Come on. Use some brains. Okay. 0 plus 0i. Here, 0. Origin. 0 plus 0i. Then minus 3 minus I. Okay. Keaton is like 5i. 5i will be here. Nice. For him, let's construct the axis more. Okay. Done. There. Okay. What else? What else? Quickly. Nice. Shashank is like this number. Thank you. Thank you. Apparently, what happened was I still remember people were giving some stupid numbers to me. And I made sure next workbook or DPP, the entire DPP, all the answers were exactly 6.9, 66.9 and stuff like that. Full sheet was filled with those numbers. Only one number. That's it. Okay. So I still remember that. Yeah. In PUC, I did that. Now, fun fact. Pi plus pi I, okay, nice. Pi plus pi I will be 3.14 plus 3.14i. That will be roughly somewhere here. 3.14 plus 3.14i. Is this fine? Is this fine, guys? I want it exact. Murali. That's all you get. Okay, nothing more. I can't do anything more than that. Nidhi, that's good. But don't expect accuracy now. I'll throw stones. She's like E minus EI. Where is E now? 2.7 something. Uh, Easier and minus 2 point. Yeah, somewhere here in this kshetra. Okay, that'll be E minus EI. Negative imaginary part and positive real part. Okay, will there be y-axis in the complex line? There's no y-axis, there's no x-axis. This is not the x-axis, guys. This is the real axis. And this is the imaginary axis. So no longer there are axes anymore. There are planes. You have to move from planes, axis to planes anymore. Your numbers lie on planes anymore. So far, numbers lied on an axis. Now they lie on a plane. Is this fine? These are not x, y, z. Nothing like that. Yeah, there's a quiz based on this. Yes, today. Okay, later. There are no axes anymore. All the axes that you had so far now become planes, big planes, sheets, which go till infinity, big sheets, which go till infinity. E is this thing, 2.17, 2.78 something. Yeah. Nidhi, you sent something, I kind of missed that. Medan sent 2 power I, okay, later, that one later. Okay, Murad is like E minus gravitational constant I. Okay, yeah, I'll do that. That's almost close to the axis. So I can draw that. Wait a second, I missed off the messages. Probably 1 second. Guys, 1 second. There's a lot of messages coming in. E power I pi later. Yeah. Shashank is like, why aren't these ideas included? Because not so important kind of thing. The attitude. Yeah. So what is I to the power in field? Sorry, I lost the field, guys. I don't. You must have just heard me say sorry. That's all. Yeah, I lost the feed. I'm sorry. Yeah. 1 second. Where is it? Damn. Where was I? Here. This is a complex name. Continuing on. Listen to this bit. Yeah. So see, on engineering, if you ask your engineering, what to say, if there's somebody is doing engineering electrical particularly, they hate complex numbers so much and imagine numbers. They make memes like this. Okay, this is a famous meme we talk about. This is a common one. It's out there. It's in the math community. Okay, they hate imagine numbers so much. Like it's so much. Okay. Yeah. So anyways, with that being said, this is how we represent. Oh my God, murdering numbers again. But you get the logic, right? So yeah. Okay, 4 plus 3. Okay, that's how. Yeah. So that's the meme out there. That's out there. With that being said, now the question is, can you compare numbers? Can you compare numbers anymore? Can you compare like 2 is greater than 3 or 2 is less than, oh my God, sorry, 2 is less than 3. Hope you agree with this. Yeah. Everybody hates complex numbers, okay? But they're fun actually, to be honest, when you understand them. Come on. Yeah. So the question is, it feels like you could compare it before. This is called ordering, okay? Ordering is a property of real numbers. Real numbers have ordering, okay? You can order them. You can say 2 comes after this and 3 after, because they fall on a line. Now, how will you compare 4 plus 3i and I? How will you compare them? There's no way you can compare them, right? You can't say I is greater than 4 plus 3i or anything like that. It doesn't make sense. It's in all directions. There are many infinite directions now. Numbers span in all directions. Got it, right? Yeah, Shashank, wait a second. Yeah. It is fine. It feels like they're in all directions, random directions. Yeah. So numbers are everywhere. This is an entire plane filled with numbers. No longer a line, number line. There's no number line anymore. It's a number plane. Okay. So ordering goes away, but we can still compare them using a metric called modulus. We treat them like vectors. So what we do is we ask them how big is a number. We call it modulus, and sometimes we call it magnitude. What we do is we calculate the distance of the complex number from the origin. How do we do that? Pythagoras theorem. You know that, right? Guys, distance formula, Pythagoras theorem. Makes sense? This length is 3, this length is 4, so this length should be 5. So we say modulus, this is a symbol for modulus. 4 plus 3i is how much? 5. 4 plus 3i is not equal to 5. By the way, 4 plus 3i is not equal to 5. But modulus of 4 plus 3, this thing, is equal to 5. Is this fine? Got this bit? I know, the real axis is not proper in position. It has some issues, some disease. Okay, I'll get it checked tomorrow. Okay, is this fine? Got this bit? It's basically the distance. It's defined as a distance from the origin, from the 0, 0. Okay, so can you tell me what's the modulus of minus 4 plus 3i? What's the modulus? Tell me. You'll get used to this. Tell me what's the answer is. It's basically square root of minus 4 square plus 3 square. Okay, that's still 16 plus 9, which is basically root 5, root 25, 5. Okay, what about this is 5? Okay, that is fine. This is fine. What about this one? 12 plus 5 modulus. 13, you guys know this. What about 12 minus 5i? That is somewhere down here in this direction, modulus of that. That is still 13. Is this fine? Getting this bit, everyone? Can I get yes or no? What about 1 plus I? Modulus of 1 plus I. Square root of 2. Is that fine? All you got to do is find the distance. So you basically, to find the modulus, if a complex number is written by a plus bi, if it is written a plus bi, then you do square root of a square plus b square. Is this fine? That's it. That's the modulus. It's called modulus. I hope everybody is fine with that. Clear? It's called modulus of a complex number. No. You can't compare still. You can't still say 1 plus I is larger than 4 plus 3i. You still can't say 4 plus 3i is smaller than, greater than, greater than 1 plus I. You can't say that. Okay. But you can say modulus. Yeah, maybe. This is fine. Got the logic? You can only compare them only when you put modulus on them. It doesn't make sense. How will you compare? How will you even compare? It doesn't make sense. It's used to find distance. Yeah, maybe you could think of it as distance. Now, here's a fun fact, guys. This is one topic I told you, right? Now, I'm going to teach you next part is something called argument. Now, I don't know why it's called argument. Why you can compare only modulus? Because modulus gives you a real number. The answer from a modulus is always a positive number, like 3 or 5, which you can compare. Got it, right? Modulus, the output of basically modulus operation converts a complex number to a real number. Not even a real positive. Okay. Yeah. Now, what is the modulus of I, guys? Quickly, I forgot to ask you guys. What's the modulus of I? We can never compare complex numbers. You can't compare them like your neighbor's kid and yourself. Okay, you can't compare them. Just a reference. Now, with that being said, 1 second. Argument, because it's an input. Oh, wait. Not argument, not in that sense. Not computer science argument. Okay. So not in that sense. So mathematicians call arguments in complex numbers for something to do with an angle the complex number makes with the positive real axis. So what does this angle tell me? Modulus phi is 1. Modulus phi is 1. Yes. Modulus of phi is 1. Modulus of 1 is how much? Tell me. 2 plus 0i. What's the modulus of 2 plus 0i? I was asking what's the modulus of 0 plus 1i earlier. This is nothing but 2 only, right? So modulus of anything remains. What's the modulus of minus 2 plus 0i? That is 2, right? Yeah, that is also 2. So the idea is that, okay? So you still can't compare, okay? But that's my idea. Modulus of I is 1, because I told you, right? This is 0 plus 1i. Okay. With that being said, can you tell me what is this angle? Can anyone tell me what is this angle? This is a famous angle. Yeah, I get it. This theta is how much? You guys know this exact angle. How much is this angle? It's actually 36.86 degrees, if you know. Okay, it's 37, 36 degrees, 36. Rounding up, it's roughly about 37 degrees. Yes. How is it calculated? It's simply take the tan theta, basically. Take the, what do you say, this part, component, 3, y, and divide by the x component. That gives you that. So we usually go with that. You take the real component and divide by the imaginary component. What do you say? Sorry. You take the imaginary component, divide by the real component, take tan inverse of that, you get 36. Is this fine? Yeah, fine, Mithil. Is this fine? Got this part? This is argument. Okay, can you tell me what's the argument of 1 plus I? Quick, tell me, easy one. What is the argument of 1 plus I? And this is a symbol for argument. Why they call it argument? Ask mathematicians. I don't know. I'm a physicist. Okay, 45 degrees. Some stupid name. It's 45 degrees. Okay, 1 plus I is somewhere here. It makes an angle of 45 degrees. Okay, what about I? What's the argument of I? Argument of 0 plus I, 0 plus 1 I, or I. 90 degrees. It makes an angle of 90 degrees. Look at that. Is this fine? It makes an angle of 90 degrees with the positive x-axis. Okay, what about minus 1 plus I? Argument of that. It's easy. Tell me. Minus 1 plus I. Careful, careful, careful. Where does minus 1 plus I come? Yeah, it comes here. Got this bit? It comes here. Somewhere here. So the angle is roughly about 135 degrees. Answer is 135. Basically, we are calculating the angle. Okay, basically, we are trying to calculate what angle it makes with the positive x-axis. Is this fine? I'm just trying to say that. So this is 1 plus I. This is minus 1 plus I. This point here. Okay. How to calculate the angle? You just take tan inverse usually, but there's no systematic method of doing this. For this, you need knowledge of trigonometry. Okay, that's why you study trigonometry first. Okay, to calculate this angle. There's some logical things you need to think of how to calculate this. But as long as if it's in the positive first quadrant, it's simple. Basically this formula works. This formula completely fails if you go to the second quadrant and third quadrant. But if you're as long as it's in the first quadrant, complex number is in the first quadrant here, this works. Tan inverse, not tan inverse, arctan, or in calculator it's called arctan. Arctan of x in your calculators usually, or on Desmos it's called arctan. Yeah. So basically, see, ultimately you don't have to know much. Okay, just know that it's the angle. Is this fine? It's the angle. That's all that matters for me. Abstract algebra is a group that comes under group theory, comes under it. Shashank. Okay. Yeah, you can play around, but you need to use trigonometry for this. How to find the angle? That's not so important. So I'm not focusing on it. Yeah. Now tell me about this one. What about this one? So before that, I didn't speak about this. So 1 second. I know there's a lot of garbage on one slide. 1 second. Yeah, this is good. Okay, now I have a question. What do you think is 2 plus I plus 3 plus I? What do you get? Sorry, 1 plus I. What do you get when you add both of them? You guys know this. This will be 3 plus 2i. Is that fine? 3 plus 2i. Is this fine? Can I get a song? Clear? Easy stuff. I like chiller for you guys. What about 2 plus 2i? Yes, Shashank, I'm connecting there. Is you're adding all the imaginary components and the real components as they are. So basically, it's like 2 plus 0i plus, I did 2 plus I, right? Yeah, 2 plus I, 1i. What does it give you? 4 plus 1i. Is this fine? I think I did 2 plus 2i, right? Or something like that. I don't know. But you get the logic, right? You guys got the logic. You add the imaginary components separately and the real components separately. Yeah. Now, with that being said, now do you see the connections? Fun fact. Where is 2 plus I? Yeah, I know. By the way, where does 2 plus, 1 second, this is not a great example. What about guys, 1 second. Yeah, 1 plus I is fine. 1 plus I is fine. So where is 1 plus I? Here, this is fine, 1 plus I. Yeah, first quadrant. What about, okay, you guys add these two, 1 plus I and add me 1 minus I. What will you get? What will you get? 2 plus 0 I? Yeah, 2 plus 0 I is here. This is minus I. Agree with this? This is 1 minus I. This is 1 plus I. Yeah, this is 2 plus 0 I. But if you remove the axis and if you throw it away, and if you throw the axis away, you'll observe something very interesting. Does it remind you of something? A parallelogram, which I can't pronounce. Vectors. Yeah. So welcome. This topic, complex numbers have everything, guys, in it. Okay. Whatever you have studied so far in mathematics, most of the things, all are connected. Okay. I know the graph is numbered weirdly. I had to murder them a couple of times, but you get the idea. Okay. So vectors work here. In fact, physicists back in the day thought they'll start using vectors. They use complex numbers instead of vectors. They thought we'll use them. They had even a plan to do that, but then something happened along the way, and sorry. Aditi, smart, good, thank you. I did a mistake here. Look. 1 plus I is here, 1 minus I is here, and 2 comes here. Is this fine? Got this part? Yeah. Vivek, fine. Even Vivek pointed out. I'll come to that, Shashank. Give me some time. Yeah. Is this fine? Got this bit? Okay. So it just behaves like vectors, guys. So physicists also thought maybe they might use this at some point, and they just discarded it. Next part is multiplying complex numbers. So, not to do with cross products. We'll come to that. Okay. What came in the way? There are some reasons. Okay. Before that, listen to this part. Multiplying complex numbers. One last thing. Okay. Before we leave, 1 plus I into I. What does it give you? Multiplied inside. That's all. What does it give you? Yeah, it gives you I plus I square. Agree with that? Which is nothing but I minus 1. Agree with that? Yeah, I'll come to that, Shashank. Which is nothing but minus 1 plus I. Is that fine? Just simple multiplication. Got this bit? Guys, got this bit? Can I get yes or no? It's simple multiplication. That's all. Yeah. So my point is, complex number multiplication works in the same way. You could multiply 2 plus 3i into 2 plus I. Tell me, how much is this? Quickly, last problem. What is this? Multiply correspondingly. 4, 2 into 2. 2 into I gives you 2i. Plus 3 into 2 gives you 6i. Then you get plus 3i square. Is this fine? Getting this part? Yeah. So this gives you 4 plus 2i. 2i plus 6i is 8i. Minus 3, because I square is minus 1. That gives you exactly 1 plus 8i. Is that fine? Does it make sense? It's 1 plus 8i. So just it works the same way. It works the same way. You just have to multiply them. Okay, multiply them correspondingly, like you multiply distributive law, basic things. Okay, so here's your break, guys. Your today there's a quiz at 7 to 7:30, and go for the break. Your class starts at 5:15. Sorry, 5:05. Okay, your next class starts at 5:05. Your next class. Yeah, Pratiksha, thank you. Got it. Yeah. So go for the break quickly. Have that whatever you were supposed to have, and you'll get just a 10-minute break quickly. Go and come. Okay, run. The next class starts immediately. Yeah, Pratisha. See you. Bye bye. Yeah, thank you, Pratisha. Bye bye. I don't know. Just go. I'm leaving. Okay. Bye bye. Shashank, I'll come to that. Why not multiply vectors like complex numbers? I'll come to that. There's a reason. There's a deeper reason. Can you explain the first multiplication? It's the same way. It's same multiply. I am multiplying directly inside. I into 1, I into I square. I into 1 is I into I is I square. That way. Okay, so yeah, that's about it. Yeah, Sakshi. Thank you. See ya. Go for the break and come. I'll see you guys. Okay, bye-bye. Pratisha, no way. Sai Pratisha, that's too late. Too late to ask. Okay, Pratisha, too late to ask. Very late. Okay, sorry. And because of social distancing, that's not possible. Even if, you know, I want to. I don't know, Medash. I'm not sure. Okay. Yeah. Okay. See you guys then. Bye bye. Take care. The reduction in break is to accommodate some timetable issues. The other teacher needs some time to get over early, so I think your class will get over early today at 6:35. So that's the reason for the break shortage. I know, Pratisha. That's on purpose. Guess what I'm doing, by the way? Eating the cake, guys. I'm on a cake. Bye bye. Okay. Nice, Neely. Good for you. Pratisha, I'm done eating the cake. What to show? Enable public chat. Okay, thank you. I forgot about that. Oh, that's not a great idea. Once again, once again. Not now. Let the other teacher come. No, that's not a great idea. Let the other teacher come. Pratisha, I think 25. What I think I was eating a cake. Why? Okay. Okay. Anyways, do submit for breakthrough, guys. And one more thing. What is that? Yeah, Nidhi, you suggested, told me to suggest some this thing, right? What is that? Links of computer science courses on CS50. I kind of forgot about that. Now I remember. One second. Who is there? I'll share. So there are some links. I open the. Where is it? Hey, can you send it here? Do you have it now? By any chance? You sent on WhatsApp, right? It's not in my email then. Is imaginary part of 4 plus 2i is 2i or 2? It's 2. Imaginary part is 2. Rules for the quiz. What rules? Normal thing. One second, one second. Keaton, yeah, your situation. I'll sort it out. I'm sorting it on Sunday. Okay, this Sunday. Hopefully that coding thing won't. Yeah, entering the numbers mostly. Today's quiz is mostly entering the numbers. Quiz is at 7 sharp. Okay, 7 to 7:30. Anywhere you can answer. Yeah, you sent it. Yeah, thank you, Pratisha. 1 second. So this is the thing. There's a bunch of good online CS50. Oh, by the way, CS50 is awesome. Okay, I've told you, recommended you. So I think Nidhi sent me this. There is not all 5 courses you'll have to browse. Okay, there are many other courses on EDX which are, I think, conducted by the CS50 staff itself, if I'm not wrong. Yeah, on artificial intelligence in Python, you can take it out. It's amazing. Looks amazing at least based on. But CS50 is amazing. That's all I know. Okay, okay, Pratisha, fine. What is the imaginary part of 3 minus 7i? Is it minus 7? Yes, it's minus 7. Minus 7. Okay, there's 4 others. Intro into. Yeah, Introduction to Computer Science is the most popular one, CS50. Oh my god, I've forgotten the spelling of computer. 1 second. Computer Science, yeah, that's fine. Yeah, that's the one, I guess. It's not the intro to computer science. Yeah, CS50 is Introduction to Game Development. Oh, web programming with JavaScript and Python, that's there. All CS50 series are amazing, so you can check it out on you. Okay. Okay. I think, yeah, Nidhi sent the other one also. Yeah, here you go. That is oh, this is an awesome one. This is my favorite. Introduction to Computer Science. This is for everyone, whichever background you're from, doesn't matter. You're welcome. Can real numbers be part of imaginary part? No, no. It's just that when I say 2i or minus 2i, that number there, 2 part, is imaginary. Is what is a real number, a real number. But then the imaginary part of the complex number is minus 2. Yeah, I know. It's amazing. My favorite set of courses. But then I did not take it a lot because I already knew most of the things they were teaching. So I was like, oh, okay. But still, there was some fun stuff, fun elements. Okay, for Sumit, Blender software is asking for graphics cards. Nidhi, what to do? I have no idea. Install a previous version of Blender, 2.78 or something. This sounds like what you did with Python. Okay, fine. Anyways, yeah, do that. Okay. Yeah. Apparently, what happened to you? You seem to be not using Blender, it seems. That's the news in town. I don't know, that's what Anita wrote. You don't use Blender anymore, it seems. No. Okay, she uses Blender. She has not left Blender. Still part of the community, and yeah. 2.8 requires graphics card. You use 2.7. That's what she's saying. Okay. Fine. Blender to make animation. She doesn't use Blender anymore to make animation. I don't know for what joy she uses it anymore, but anyways. Okay. 1 second. Anime. Okay. Fine. Okay. By the way, she knows the difference between anime, cartoon, animation, and all that stuff. So be specific with the words. Okay, when you ask her. Okay. Yeah, I'm sorry, Vivek. I get that. Yeah. Okay. Anyways, I think I'll make a move. We're done. The teacher is here. I'll enable the private chat. 1 second. Yeah. Then I'll be done. Bye bye. See you guys.
Students, can you hear me? Students, if you want, you can drink water right now. Okay, I'll give only 1 minute time because I'm going to end my class at 6:30. Yes, yes, you drink 1 minute time will be given to you. You drink a coffee or else water within 1 minute. Okay. And then other students are asking that about the quiz. Okay, today there is no quiz because I cannot write the name of the compound without discussing this nomenclature rules. Once if I complete this nomenclature rule, I can give quiz. Okay, students, 1 minute is over, right? Come. Students, whether we have discussed these things, first rule is over, right? First rule, what is that? Select a longest chain. Two rules are done. Okay, so what about the next rule? Next rule is also over. Students, what about this? This problem is over. This is over. Then what about these two? Whether it is done? These two? Yes, okay. And what about the lowest number rule? Everything is over. Okay, students, you just recall once. Okay, if this is the situation, this is the molecule. If you want, you can note down. Or else if it is written, you can leave. Students, so this is the molecule. So the first rule is nothing but identification of a long chain. And second rule is related to the lowest number rule or else the lowest locant rule or else the lowest position rule. This is a single bond, okay, not double bond. This is hydrogen. CH3 single bond it is, okay? Single bond, single. Now students, one branch is there here, correct? One branch is there. If one branch is there, then how to select the path? That is, you can give number from left to right or else right to left. Okay, so from here to here or else here to this direction or else this direction. If you select this path 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4, then this substituent will get at least number 3. Okay, substituent will get a number 3. Suppose if you do from right to left, so at that time this is 1, this is 2, this is 3, this is 4, then substituent will get a least number, that is 2. Which one is proper? So left to right, if you do, substituent will get the number 3. If you do it from right to left, substituent will get number 2. Which one is right, students? Yes, the second one, that is from right to left, a substituent must get a least number. Okay, is it clear, students? Can I rub this? This is 3, okay? You write this molecule. Exactly same position I gave. Or what? Vivek? Same molecule was taken. Same molecule. No. Yeah, you write this molecule because here some twist is there. So you write this molecule. Students, first you follow the first rule as well as second rule here. Apply first rule as well as second rule. Now, first rule is nothing but a length, okay. Then what about the second rule? Second rule is nothing but related to the position of the substituents, okay, position of the substituents. Now, let me number from this direction. Students, you write in one in pen, one in pencil. At that time, you will come to know the difference. Students, you write this one left to right, from your left to your right, okay. 1, 2, 3, 3, 4, 5. 5 means this carbon, okay, not branched one. This is 6, this is 7. How many carbon atoms are there? Total 7, okay. This is from left to right, and you give same number from right to left. 1 for see, I'm giving number for this carbon, okay, this carbon, this chain is there, right, for that, but I'll give right here, okay. 1, 2, 3, 4, 5, 6, sorry, 6 and 7. That means from your right to your left. Over. Now students, you just take this left to right, means the first position, okay, first method, that is from left to right, okay, that is from left to right. If you number like this, what are the positions of the substituents? So just concentrate, students, here. If you number from this direction, okay, this to right, sorry, your left to your right, then 1, 2, 3, okay, at the third position you have one substitution, and 4, 5, at fifth position you have one more substituent, right? And you select one more path, that is nothing from right to left, once again. So 1, 2. At third position, you have a substitution. And once again, at the fifth position, you have a substitution, students. Correct? Yes. Now, which one is proper? Which one is proper? First rule is proper. You have selected longest chain. Okay. So you have selected longest chain. Then second rule is also proper. You gave least number for substitution. But if you number it from left to right or else right to left, then substitution is there at 3, 5. In first position 3, 5. In second position also 3, 5. At this time, one more rule is there, okay, that is given later, okay, but I will explain here only. Here only I want to express it, okay, that rule. See what, so if this is a situation, same means equivalent position, right? From that direction, from left to right, it is equivalent, and right to left also it is equivalent, equal length, correct? So at that time, what you have to do? You concentrate on the substituent group. So what is this group? Can you tell me the name of this group? Yes, ethyl, correct? Ethyl, C2H5 ethyl. What is the name of this group? Methyl, okay. See, ethyl, one group, and one more is nothing but a methyl, which comes, see, according to the, not Sumedh, I will tell, wait. One is ethyl, one more is methyl. Okay. So, now, where to give a least number? To which carbon atom? Or else where to give, means which direction is to be selected, that depends upon the name of the substitutions. See students, this substitution name starts with ethyl, this substitution name starts with methyl. Okay, so which one comes first in the alphabet? A, B, C, D. Which one comes first? E comes first. So therefore, if this is a situation, equivalent position is there, then concentrate on the alphabetical order, name of the substituent, concentrate on the name of the substituent, and if substituent comes, its name comes first in the alphabet, then that substituent will get the least number. Same letter, okay, Shashanka, that is the third rule I will discuss there. Shashanka V, I'll discuss there. Okay. So if this is a situation, if this is situation and with the same substituent, the same equivalent, one more example is there. Okay, I'll show you. See students, now what you have to do, one is ethyl, one is methyl, then E comes first in your alphabet. So therefore ethyl has to get least number. Students, now tell me which direction is proper. Which direction is proper? Yes, the first one. First one is nothing but from left to, from your left to your right. Okay, from your left to your right. This method is proper. So let me remove this or else. Okay. Wait, whether I have a eraser option here. What is this? No. One minute, students. Can't minimize this slide. Okay. No, no eraser. Okay, it is there. Okay, students, now we have to give number here like this 1, 2, 3, 4, 5, 6, and this is 7. Okay. Oh, here CH2, sorry, single bond. Okay, C2H5 is there, C2H5. Students, now how to write the name of this compound? How to write the name of the compound? Okay, so nomenclature part, you just remember 3 parts are there. First name starts with the primary prefix. Whether primary prefix is there for this? Primary prefix is related to the students. Primary prefix I'm asking. Primary prefix is related to the cyclic compound. Whether the given compound is cycle, it looks like a cycle? No. So therefore there is no primary prefix. No primary prefix. Okay. What about the, yes, what about the secondary prefix? You just recall what that secondary prefix relates to. It is related to the branches, right? Branches. Okay. So now whether this compound has a secondary prefix? Yes, there is a secondary prefix. So what you have to do, students? Two substitutions are there here. One is ethyl, one more is methyl. So you have to write, not di. Wait, Shashank. So if same group is repeated, means here also CH3, here also CH3, then I can write it as di. Here one group is ethyl, one more group is methyl. So I cannot write it as a di. Students, just wait, I'm explaining. Okay, see. Which one comes first? You have to write the name of the substituents according to alphabetical order. Write the name of the substituent according to the alphabetical order. Which one comes first? Ethyl comes first. Next, methyl. Now what you have to do, students? Represent the position of ethyl group. Represent the position of ethyl group. Where is this ethyl group? To which carbon atom it is attached? Means main chain you check. This is the parent chain, right? So to this parent chain, you can observe, you can have the substitution of this ethyl at a third carbon atom. Students, all of you write it as 3. Yes, Suman, correct. See, it is 3. After that, what you have to do, Suman, it is wrong. Okay, some mistake is there. See, wait, I will explain. After 3, you have to write what is the name next. You have to write ethyl, right? Students, remember, name as well as numbers are separated by hyphen. Okay, remember, names as well as a number as well as a name is separated by hyphen. Okay, then sometime you may have same substitution at same carbon, means you may have two substitutions at the same carbon atom. At that time 2 you have to write, or else 3 you have to write. If that is the situation, see, not in this case. Okay, suppose if you want to write two numbers together, then two numbers are separated by commas. You remember these 2 points. Okay, two numbers are separated by two numbers, not in this example. Okay, so second rule is not applicable for this example. See, two numbers are separated by not only two, you can two numbers are separated by comma, and number as well as a name is separated by hyphen. Okay, so it is 3. Okay, then next, Anika, why it is 3? You give me answer. Why it is 3? No idea. No idea? Means what you're not at all concentrating. That is the answer from my side, my idea. Correct? So what I told, see, first you select the long chain. Here two methods are there. You can concentrate from your left to your right. Okay, left to right. And one more numbering method is done from right to left. That is your right to your left. Okay, two possible methods are there. If I number from left to right, then here I will get branch, that is at the third position, as well as here I will get a branch, that is at a fifth position. Is it right? Left to right. Okay, then next situation, you number it from your right to your left. So that is from here to here. So at that time, this is 1, this is 2, this is third. Okay, then this is 4, 5, 6, 7. Okay, so once again you will get branches at a 3, 5. Is it right, Anika? Branches may be different, but positions are same. Medanash, completely wrong. Answer which is given by you is completely wrong. Okay, so this is the situation. Is it okay, Anika? Anika, is it clear? Yes. Now, if this is a situation, which path is to be selected? See, least number, yes, least number in both the case. You got least number in both the case. What about the chain length? Chain length is also here. It is all here. It is 7. Here also it is 7. Then what to do? Rule says that if this is a situation, rule says that, wait. If this is a situation, rule says that you have to give least number, or else you have to select that path in which least number is given to that branch which comes first in the alphabet, E. So to identify this, you must know A, B, C, D. Over. This is E. So this path is proper. Is it clear, Anika? Okay. Now you write the name here. 3. What you write? Ethyl, because eth comes first. E comes first in the alphabetical order, right? Ethyl you write. Over one substitution you wrote, one substitution. Then once again you put a hyphen because you have to write one more substitution. One more substitution is there at the fifth position. So you write 5. What is that position? What is that substituent? A substituent is a CH3. The name of that substituent is a methyl. Okay. Secondary prefix is over. Secondary prefix is over. So students, here someone asked, why can't I write di there? Okay. See, both substituent groups are completely different. One is ethyl, one is methyl. So therefore you cannot write it as di or else tri, etc. Okay. Now 3-ethyl hyphen, once again, why hyphen? Number, name as well as number. Here also hyphen, name as well as number. Students, next one is a root word. Which one is a root word here? 7 carbon atoms. So that is equal to hept. Students, there is no gap here. There is no gap. You write it together, okay? Hept, then, okay, over. Root word is over. Root word is hept, okay. Then what about the primary as well as secondary suffixes? Secondary suffix is related to the functional group. Whether functional group is there here? No. So therefore only primary suffix is there, right? What is that? It is related to the single bond, double bond as well as triple bond. Okay. So what bond is there here? Single bond is there. So therefore name ends with the ANE. Okay. Name ends with the ANE. So you write it together. Okay. ANE together. So what is the name of this compound? 3-ethyl 5-methyl heptane. Is it clear, students? Is there any doubt? Someone wrote 3-methyl first. 3-methyl. It is wrong. Why 3-methyl is wrong? Because M comes later. E comes first. Okay. Students, you write down the molecule. Okay, write down the molecule here. And here correct method as well as wrong method both are given. Ma'am, the first word should start with the capital. Yes. First one is capital. Remaining everything is small. Students, you write this one. I will zoom it. Wait. No. Okay, write this molecule. See, this is CH3, okay? Write this molecule only, first molecule. Don't write the name of the compound. CH3, CH, then next once again CH3. Whether I have a free space? Not required. I'll write here only, okay? It's done. Okay. CH3, CH, CH3, CH2, CH3. Okay. Whether yes, whether it is over first molecule. Yes. Okay. So what is the method? First, you have to identify the long chain. Okay. Long chain. That time I asked why 3 first and 5 later. I understood. I was listening, ma'am. Okay. I asked a question 5 minutes before. You are giving answer after 5 minutes. Okay. 3 because E is there, E is attached, ethyl group is attached to third group there. Okay. So now you concentrate on this. So CH3, CH, CH3, CH2, CH3 is there. So you have to identify the long chain. Long chain contains a 4 carbon atom. You can number from this direction, left to right, or else right to left. This one, right to left. So two possible methods are given, but one is wrong and one more is correct. See, if you select this path, the substituent will get least number, that is at the second. Substituent group is there at second carbon atom. If you number in this direction, substituent group is there at the third position. So which one is least? This one is least, right? So therefore this method is proper. So you select a number or else give number from left to right, left to right. 1, 2, 3, 4. Now you write the name of the compound. The name starts with the primary prefix. Is there any primary prefix for this? No. Why? Because it is not a cyclic compound, right? It is a straight chain over. Then next, what about a secondary prefix? Yes. Secondary prefix is related to the substitution, right? Yes, a secondary prefix is there. So you mentioned the branch where? So at the second position. No, I have a different option here. No need to do that control scroll everything. But I did not get at that time. If I do like this, I can't write. Pen option is not there. Okay. So you can write the molecule. It's over, right? You have written the molecule, right? So see, only hand option is there. Pen option is not there. Okay, students. So here, 2, okay. Then write, where is pen? Okay, then at the second carbon atom, you write a secondary prefix. A secondary prefix means at the second carbon atom. Second carbon atom means at you concentrate on this main branch. Main branch. At the second carbon atom, you have a main chain. Okay, parent chain. At the second carbon atom, you have a branch. So therefore, 2. Okay, then which branch? What is the name of the branch? It contains CH3 group. CH3. CH3 is nothing but a methyl. So starting letter must be capital. So you write a methyl over. Then next, okay, secondary prefix is over. Next comes a root word. What is the root word for this compound? 4 carbon atom. Yes, bute. Okay, bute. And what is the saturated or else unsaturated? Means what is the primary suffix? Primary suffix is related to the saturation or else unsaturated compound. So here it is saturated one. So name ends with the A and E. Students, tell me whether any secondary suffix is there here. Functional group is there. OH, CHO or LCOH, no. So therefore this is the name, correct name. This is the wrong method, students. If you give number from right to left, see this will carry more number. So therefore this is a wrong method. Students, now you write the second one. I'll repeat CH3, CH, CH3, CH2, CH2, CH3. Okay, students, you start from primary prefix. Whether primary prefix is there for this, students, you have to write it fast, okay? Whether primary prefix is there for this. Take down for, in your notes also you have to write, and in message also you have to write. Or else, students, I do one thing, I'll unmute you all, okay? Not unmute, but one option is there here. Okay. Mute all current and new participant, not like that. No, it's not there here. Okay. Okay, so what about the primary prefix? Primary prefix is not there. And what about the secondary prefix? The secondary prefix is there. Okay, so secondary prefix is related to the substitution. Substitution group is there, right, Anika? Okay, so therefore secondary group, secondary substitution is there. Okay. So secondary, you just select the path 1, 2, 3 from left to right as well as right to left. If you give number from right to left, then it will. I told it to. Okay, Anika. So now this will give you number 4. This will give you number 2. Which one is least? The second one is least. So therefore, let me select this path. Means numbering from left to right. Okay, numbering from left to right. So branch is there at a second carbon atom. So it is 2. And which branch is there? That is nothing but a methyl. Okay, methyl. And what is the root word? Root word is a pent. Okay, root word is pent. And what about the saturation? It is a single bond is there. So therefore name ends with the A and E. This is the answer. Note on the third one. Third one is also done, na? Mithul. No, okay. You write the third molecule. CH3 it is, okay? CH3, this is CH, then CH3, then single bond CH, then double bond CH2. Now, see students, you select a path. Select the path, okay? Okay, this is the molecule. Students, you select the path now. Okay, you select the path. Okay, now you select a path. Students, this is the compound. Select the path. You can give number from right to left. Sorry, your left. First you start it from, usually most of the molecule, for most of the molecule, left to right, usually you can observe that type of numbering. Okay, therefore first you start with the left. Okay, but not all. Okay, you can also have exceptional cases. Means it depends, students, where you write your attachment. Means attachment means as well as substitution, as well as double bond, triple bond, etc. Okay, it depends on that. So this is one method, from left to right, one method. Then another method, 1 2 3 4, that is from right to left. One more method is there, students. You can give even number 1 here, 1 2 3 4. Okay, this is the third option. You can also give one more option. You can give one number to this, 1 2 3 4. So you students, you just check first one is there, right? Here, this as well as the fourth method, fourth option is same. Sorry, second as well as third option is same. Okay, so let me remove this. Let me remove this. So let me remove this. Let me concentrate mainly on these two paths. Okay. Wait, man. Okay, students, so two paths are there. Now you select this path left to right. Students, don't write anything. Okay, you select this path, whether longest chain is there, long chain. If you select any path, means from left to right or else right to left, carbon number remains the same, right? 4 4. There is no variation. Then what about the substituent, students? If you select left to right, then a substituent will get a least number, right? What is that number? 2. Okay. Now you take this one, upper part, means the second method. Okay, this is the first variable, first one, for first method. Second method is like this, means from give number from right to left, right to left. So what is the chain length? Chain length 4. Correct. What is the position of the substituent? Which number? 3. Correct. Position of the substituent 1, means one number is to be given to this, 1 2 3. So therefore 3. Okay, so which one is the least, students? According to the law, I have to obey this one, right? Yes, sir. Which one is the least? First one. Okay, according to the law, I have to obey this one, right? Yes, sir. Students, now there is a twist. Students, whenever you have a single bond as well as a double bond in a given compound, whenever you have single bond as well as double bond in a given compound, then double bond is to be given. See, you have to give more priority for the double bond. Double bond has to get least number. Least number means highest priority. You have to concentrate on that double bond first, then single bond. Even though how many attachments are there, that will not count. Okay, so if a single bond as well as double bond is there, you give concentration for double bond. Okay, now in the given compound, single bond as well as suppose in the given compound single bond as well as triple bond is there, then triple bond carries more priority. Okay, highest priority. So therefore one number is to be given to this triple bond. Imagine in the given compound, one single bond, double bond as well as triple bonds are there, then more importance is given to triple bond. The next one, okay, this is a first rank and this is second rank and this is third rank. Okay, is it clear, students? Yes. Which one carries first rank? First rank means more priority one, more priority. So usually the compound name ends with that highest priority substituent, usually. Here, whenever you have a single bond as well as double bond, name ends with the E and E. Whenever you have a single bond as well as a triple bond, the name ends with the Y and E. Whenever you have a single, double as well as triple bond, once again name ends with the Y and E only, because a triple bond will get more triple bond will get more priority. Sakshi, you asked the same question after 5 minutes. Okay, let me complete this. You remind that. Students, whether this is clear? How to give a priority? Okay, now students, here two options are there. Okay, left to right as well as right to left. Which method is proper? Which method is proper? Now you just concentrate on the rule. Left to right, okay, if you select the left to right path, the substituent will get the least number. Okay, but what about the double bond? Double bond carry, see here, substituent will get least number, double bond carry fourth number, 4 number. Here substitution will carry 3 number, but double bond will carry 1 number. Okay, Mithil, what is this? Mithil, same question you write once again after 5 minutes. Okay, let me complete this first. Okay, now where we are. Okay, if you select this left to right path, then a substitution at a second position and double bond is at the fourth position. And if you select this right to left path, this is a substitution at the third position, and then this group at double bond at first group, first position. So now which one is proper? This one is proper. So you have to number this compound from right to left. Okay, this compound is to be named from right to left. Okay, so therefore here you just check one number is given to this carbon. Okay, one number is given to this carbon. Students, don't send any message. Okay, so let me complete these two situations, the two examples first. After that I will concentrate on your questions. Okay, so now here double bond. Okay, you give more concentration to this double bond, so you write it as 1 here. Give more priority for this. This is 1, this is 2, this is 3, this is 4. Okay, Shashank, I know that I told you to concentrate on the theory, what I'm going to explain. Already I explained, don't copy anything from this without, see, after explanation only you have to write, because this is a textbook copy. I already explained there are so many corrections in this, so many mistakes are there. Okay, if you write it as a Y and E, I'm not responsible for that. I did not tell you to write like that. Okay, so now Now CH3, CH, CH3, CH, CH2, one number is to be given to this carbon atom. Select this path. Okay. Now write the name of the compound. Write the name of the compound. So start it from the primary prefix. Whether primary prefix is there here? No. So therefore no primary prefix. And what about the secondary prefix? Yes, there is a substitution. Yes, there is a substitution. Where? At the third position. At the third position. Okay, not try, at the third position it is 3. See here, spelling carries importance here. TRI if you write, then meaning is different. THRE if you write, then meaning is different. Okay, so at 3, what substitution is there, students? CH3. CH3 is called methyl. First starting name, you write it as capital letter, so it is methyl. Methyl over. Secondary prefix is over. Then you have to write root word. Root word, you count the number of carbon atom. That is 4. So you write, students, you just write only bute. You cannot write butane because a double bond is there here. You write bute. Root word is over. Okay, then students, you have to concentrate on the primary suffix. Primary suffix. What is that primary prefix? It gives the information about the saturation as well as unsaturation. So which group it is? Since a double bond is there, unsaturated compound, you write it as ENE. So what is the name of the compound? You can write it as a 3-methyl butene. This is one option. You can write one more option here. See, one more. Wait. You can also write one more name here, students. Can you see here? Position is mentioned, students. There is a correction. This is not Y. This is actually E because double bond. What is this, Viveka? So that one can be ignored. Yes. Yes, students. See here, usually you will write some reactions there. Nothing is given in front of that. Means what is the meaning? One is there. That is the meaning. Yes. Students, if you ask any other question, I'm not able to answer right now. So let me complete this. After that, I will concentrate your, I will give answer to your question. So now, students, you can also write it. One option I gave here, right? That is nothing but a butene. Together you can write. So that indicates double bond is there after 1. Okay, double bond is there after 1, students. And here once again 3-methyl bute, that is same thing. 3-methyl bute. Okay, I don't have space. Let me write here. You are writing number, so therefore write hyphen. Students, here number 1 is written. Why 1? Why 1? Because you concentrate on the structure. Double bond is there after what? After what? After first carbon atom. Always remember, students. See, students, even though it is wrong, okay, don't write this. This is wrong question. Okay, means wrong selection of path number. But this in this, even though it is wrong, here numbering is done from left to right. Correct? So therefore, double bond. Where to write a double bond? Always remember after. Okay, these are all same. Not 4. You have selected this path. You have to concentrate 1, 2, 3. Not from 4, 3, 2, 1. Okay, increasing order. So 1, 2, 3. After this third position, you have a double bond. So therefore, that is to be mentioned at 3 carbon. What is the meaning of 3 in? Means at a 3 carbon atom. Means after third carbon atom, you have a double bond. That is the meaning. What is the meaning here? After the first carbon atom, you have a ENE, means double bond. You can write this one, or else you can also leave this one. No problem. Always. But if 2 is there, or else 1, see, if double bond or else a triple bond is there at first position, you can write it, or else you can leave it. No problem. Anything, if you consider nomenclature, in case of nomenclature, anything is there at first position, you can mention it, or else no, you can also leave it like that. It is understood because it is there at first position. That is the thing. Okay, meaning. Suppose if it is there at a double bond is there at a second position or else third, fourth, fifth, at that time what you have to do? You have to mention the position. Is it clear, students? See, it's over. Now you write the next compound. See here, one correction is there, that is ENE. Okay, ENE. Okay, Nidhi, you are asking 2-methyl. Okay, 2-methyl. 2-methyl butene. What is the structure of this compound? Let me write here. What is the wait? 2-methyl, right? Okay, 2-methyl. What is see name you gave, right? Butene. Okay, you have written like this, right? Butene means first you write the 4 carbon atoms. Okay, you write the 4 carbon atom. Okay, 2-methyl. Okay, let me write like this. And butene means this is the structure. Someone asked this question, ma'am, can't it be 2 from the left? Yes, it can be. It can be because the same length, right? You can write anywhere. Okay. But what was the question? Question was completely different. It is there at a third position. Someone asked this question. I don't know who is that. Anika? Not Anika. Someone asked a question. Nidhi? Yes, Nidhi. Is it clear, student? Nidhi? Structure will be different completely. See, this is the structure. Okay. Then, okay, so many questions are there. Let me, for this compound, can't it be 2? If you take 2 from the left, what I gave answer now? Yes, you can also write, okay, you take 2 from the left. Okay, leave this. First, let me give answer for Nidhi's question. From the left you want, right? Okay, let me write CH3, CH2. Okay, CH, let me write, wait. You want 2 from left, right? Okay, I'll write here. But what is your name? Means your name in the sense compound name. So it is 2-methyl. Okay, at second position. You see here it is 1, 2, 3, 4. What is the name? 2-methyl butene. Correct? Butene means one here double bond is there at the first position. Okay. Now you want it from the second position, right? Okay, you write here double bond. What is the name? Name, same name. But numbering is to be done from here. That's it. Is it okay, Nidhi? No answer. Okay. Okay, then now. So how will we take, how we know whether a compound is from left to right or else right to left? No, the what I told, first rule as well as second rule. So first rule as well as the second rule explains you how to select select the path from right to left or else left to right. Once again you read it, Nidhi. Okay. Nidhi, you turn on your mic and talk. You have so much of confusion after studying it in detail. Okay, Mithul is asking something. What is it? No, ma'am. I will go through go through. I clear my doubts. I clear. So, yes, Nidhi, once again you go through to that means between first rule as well as second rule. You read it once again. Okay, that will tell you how to select the path. How to select the path. Okay, after that, if any doubt is there, tomorrow you ask, or else see now there is a question time. Okay, so many questions are there here. I will answer all these questions at that time. You read and then later you can ask. Okay, Nihad, I will give so many examples. You just wait for that. Okay, here so many questions are there. Let me answer all these. Students, now stop sending message because I am here at the top of the list. I can't see your message right now. So first one position, ma'am, why can't it be 2-methyl butene? That is over. Okay, then who is this? Mithul. Ma'am, if a chain contain, okay, let me write 6 carbon atoms. So he's asking write 6 carbon atoms. Okay, write 6 carbon atom. 1, 2, 3, 4, 5, 6. Okay. And either way we go to double bond, will get it 3, then we consider for single bond. What is the meaning of this English? I did not get. Mithula, you do one thing. You unmute and then ask. Unmute, unmute. Ah, yes. Where I can put double bond here? You tell me what type of molecule you want. Are you talking? You unmute, unmute. It is actually mute. You do one thing. You write the molecule and show it to your camera. I'll write here. Okay. Yes, Anika, you're asking if position is not 1, then you have to write the number. Yes, Anika, correct. If position is 1, then you can leave or else you can also write. But if position is 2, 3, 4 and all, at that time you have to write the position. Over. Whether molecule is there with you, Mithul? Yes, so show it to camera. I can see here. Not ready? You write this 6, you gave one problem, right? I understood only this part. Okay, write 6 carbon. I wrote this. Okay, then you are telling to write some double bonds, but that English is not proper, so I cannot understand it. It is difficult to understand. Okay, so you write that molecule in your notebook and show it to me. I will write here. Okay, so then one more, ma'am, can't it be 2 from the left? Okay, Nidhi, it is over, right? Shashank is asking, ma'am, can we write that attachment to third element instead of the second one in its structure? Does it make some difference than name? Okay, we'll check what is that molecule. This one, right? Which molecule? Which molecule? Shashank, you unmute and tell me which molecule you want. This one or this one? Shashank MN. Shashank MN, at least send a message. Which molecule you want? Third one or else fourth one? Third one. Okay. So what you want to do? You have to write it to the this one, right? Correct? I could not unmute. Okay. Okay. You write here. You want that CH3 here, right? Okay. Then remove this CH3. Or else you want a CH3 at the both position, means 2 as well as 3. You write, right? No, ma'am. No, ma'am means what I have to. Okay, one position. One position. I think no, ma'am means it is one position. I think like that. At the third only. Okay, at the third only. Okay, it is there at the third only. What is your problem then? You, Shashank, you do one thing. You write that molecule and show it to me here in the camera. Shashank MN. Wait. I'll. Where are you here? Amit, we can't see your face. Shashank, 1 minute. Oh, I can't see that one, right? CH3, CH. Okay. This one, right? Shashank MN. Yes. What is the name of what you want? You want to know the name? Okay. This actually Anika asked the same question. So what is the name? So you give one number to this because here double bond is there, right? Double bond gets more priority. Okay, double bond gets more priority. You write 1 here. Okay, then 2 to this, then 3 to this, then 4 to this. Okay, so therefore what is a name? A name starting from the primary suffix. Okay, ma'am, will it change anything except the name? No, except the name. What I told, nothing. 2 methyl bute 1 ene 1 ene. Except the name. See, Shashank MN, I'm concentrating only on the name now. Except the name means what you are expecting. Tell me. I did not discuss its physical property or else anything. I did not say anything. Some property. Yes. Yes. There will be a change. Okay. Next, ma'am, we was carbon and its compound text and workbook are removed. Ayyo, devre. Now you concentrate on this one. Okay. So later, sufficient time is there for you. You check it in the Schoology part. Okay. Wait, students, stop sending message. So many questions are there here. Let me answer all those. Oh, Mithul, your this one is ready, right? Mithul, where is your photo? Mithul, show me that molecule. Show that molecule. See, I can see only the background picture, not you as well as your book. What you have written in that? Keep it once again nearer to the camera. Okay, wait. CH. Okay, which is wrong. Once again, up. CH3, CH3. Okay, double bond. Okay, third carbon atom. One here, double bond here, and one more single bond. And this side, you show this side. Okay, that side. CH3. 1 minute. This side. Keep it nearer to the video. Okay. Remove that. Write 6 carbon atoms. Okay. 1, 2, 3, 4, 5, 6. Here double bond and here CH3, right? Mithul, shake your head so that I can confirm that molecule. Where is your head? Is it clear? Is it right? Only this much, right? Ah, yes. Now what is the name of the compound? One hydrogen, here one hydrogen, here one hydrogen, here CH2, here CH2, okay, here CH3. Okay, what is the name of this compound? Students, from where you have to give one number? Numbering is to be given from students. Other students are also, you can also write this one, okay? It is even useful for you also. Yes, students, numbering is to be done from left side. Why? See here, substitution is there. First, second rule, see, concentrate on the second rule. Second rule says that substituent must get least number, means you have to start from the left hand side only, right? Okay, if you start it from the right hand side, 1, 2, 3, 4, fifth position, okay, this will carry 5. But if you start from here, this will carry 2, okay. But, okay, I think you are asking whether we have to start a number from this carbon atom, right? Double bond, right? So you have to get, this double bond has to get a more priority. No. If double bond is there in the middle, at that time, what you have to do? So nearest end you have to select, nearest short end you have to select. You cannot start from here because it is far away from this end, okay? You have to start from here. This is nearer to this double bond. Is it clear, Mithul? 1 minute, let me see your face. Is it clear, Mithul? Okay, you should not start from the double bond there. Okay, you have to select, if this is the situation, you have to select the nearest carbon and nearest chain end. Okay, this left side is a chain end one. Okay, this is the starting one, this is the end. Or else if you consider this is the starting one, this is the end. Nearest end is nothing but this one. So you give number 1 to this. Okay, let me take eraser. Okay, hydrogen is there here. Wait, Mithul. First, let me give answer for this. See, this is 1, this is 2, this is 3, this is 4, 5, 6. What is the name of the compound, students? First, you write a primary prefix. Whether primary prefix is there? No. So, starting from the secondary prefix, 2 methyl. Okay, 2 methyl over. Then, root word. Root word, it means contains 6 carbon atom. 6 carbon atom. So, it is hex. Okay, over. Then, can I write ANE here? Can I write ANA? No, because double bond is there. So therefore, I have to write a double bond. But write the position of the double bond. See, while writing the position of the double bond, you have to write that number. After that, you must write double bond. First write that number, then means, see here, 2 as well as 3, if you, there will be usually confusion for students, okay? 2 as well as 3, which one is to be written first? Which one is to be written here? Okay, it is nothing but a 2, not a 3. Means after 2, so this is the direction, right? Left to right. This is the direction. After second carbon atom, you have a triple bond. So therefore, after what? That you have to write, Suman. Lazy. Hex 2 means after second carbon atom, you have a double bond, correct? After second carbon atom, there is a double bond. And then what is the name end? Ends with what? Amog and Shashank MN, what are you doing? You are laughing at each other or else what? No? Is it clear, Mithul? Okay, you have another set of questions. Today I have to complete that nomenclature part. How many minutes more? Ma'am, I am not laughing. Okay, leave that. But the previous, what? Wait, okay, stop. Stop for answers related to laughing. Okay. What if the double bond? What if the double bond was in the next carbon atom? Okay. You want to place this one, remove this one. So this is actually homework for me or else you? Huh? You have to try, okay? You write all those options and try the name. And later you can ask if you have any doubt. You are giving all questions for me to solve. Okay, now what is the balance the carbon atom here? Okay, 1, 2, 3. 1, 2, 3. CH here, all right? 1, 2, 3, 4, 5. Here, this is CH, okay? CH. Now, what is the chain length? Okay, you only tell who is that? Mithul. Branch is there, branching is there, double bond is there, branching is there, double bond is there. Branching position from here, if you consider from left to right, this is 1, this is 2, 3, etc. Okay, branch carries 2 number as well as your double bond carries 3 number, because after third carbon and you have double bond, right? Okay, now you start numbering from, you give number from right to left, right to left. So this is 1, this is 2, this is 3, 4, 5, 6. Okay, so in these two cases, in the second case, so this is from left to right. Okay, left to right. If you consider right to left, so triple bond is there after third carbon atom only. Okay, what about the branch chain? Branch is there at a 5th position. So you select a least number. See, in both the case, double bond is there after 3 only, right? After 3 only. Then which one is more proper here? You have to select this path, left to right. Is it clear why even branch will get a least number? Okay. Let me give answer for Shashank whether I solved his doubt. Okay, this is over. Okay, someone is asking a CH2. See, CH4 is nothing but methane. CH3 is nothing but methyl. CH2 is nothing but methylene. Okay. Okay, Mithul, forgot formula. Okay, good. Whenever you remember that formula, you write it down and then write the name. Okay. Ma'am, that's impossible to have CH3 in the chain, no? In chain, in between, see, if you have a chain, CH3 will come at the end. Okay, not in between. At that time, carbon valence exceeds 3 plus 2, 5. It becomes a 5. It is wrong. Okay, then someone is asking, ma'am, what is the double bond was next to, okay, that is solved. Yes, always you have to consider double bond, position of double bond after the, see, you have to write double bond here. See here. After one you have a double bond, right? So therefore you mention it as 1. You can't mention it as 0. Right? What is, Mithul is asking, what is CH? CH is nothing but a hydrocarbon. Compound containing carbon as well as hydrogen. Special name is not there for this. Okay, Anika. If double bonds are there, then from where to start? Okay. If this is a situation, you can start from any direction. Any direction. If this is the situation, remove this. Okay. If this is a situation, then also you can start it from this direction. This will carry least number. At that time, if you start from this, then this will carry. See, this is 1, 2, 3, 4, 5. So positions of double bonds are nothing but 1 as well as 3. Then here it is 1, 2, 3, 4, 5. Positions of this here it is 2 and 4. So you have to select this one, first path. Okay, so you write more twisted problems by your own and try it. After that you ask, because it is very, very simple one. Correct. Then students, let me, okay, what about the last one? Students, you just concentrate here. The last, write down the last molecule, CH3 CH, write it fast. CH3 CH, CH3 C, triple bond it is. Okay, triple bond, triple bond CH. CH3 CH, CH3 C, triple bond CH. So if this is a situation, now once again see, single bond is there, double bond is there, sorry, single bond as well as triple bond is there. So therefore you have to give least number for the triple bond, correct? So therefore numbering is to be done from right to left. So here first you write, start it from the primary prefix. Cyclo is not there, so go for a secondary prefix. Secondary prefix is related to the substitution. Substitution is there at a third position, so it is a 3-methyl. 3-methyl. Okay, then next, what is a root word? Root word is nothing but a bute, so it is bute. Okay, then you can also write YNE together here. No need to mention the position because it is there at first carbon atom, or else one more proper name. You can also mention the position. Okay, 3-methyl bute you write. You cannot write ANE because unsaturated compound, triple bonds are there. You write the position of a bute, triple bond. Triple bond is there after first carbon atom. So you write 1. Then next, what is the name? Ends with the E, YNE, ine. Okay, YNE. Rahul, where you went? Okay, this is the answer. Is it clear, students? You write this molecule and later you can write the name. Yes. Students, next one, this is already over. Students, if this compound, I think, yes, you note down this compound first. Note down this compound first. Their name as well as compound does not match. CH3, CH, CH3, C, CH3, CH3, CH2, CH3. Even this explanation also does not match. Students, you do one thing. You write here as a C2H5. C2H5. Okay, alphabetical arrangements of prefixes. If there is a different alkyl substitutions present in the chain, okay, present in the compound, their names are written in the alphabetical order. So this example I gave. See here somewhere I wrote a 3,5 dimethyl. Where it went? See this one. See here, two substituents are there. Actually, one is CH3, one more is methyl. One is methyl, one more is ethyl. Here, two substitutions were there, right? But where to give least number means a number less number, or else one number highest priority is to be given to that substituent which comes first in the alphabet. That is the meaning. Okay. So I gave explanation in the beginning, but they are giving rule now. Where is that? Okay, so this is C2H5, and don't concentrate on this name. This is completely wrong. and even the structure as well as name does not match. See, let me take and to match this explanation, I changed this molecule here as to C2H5. CH3, CH, C2H5, C, CH3, CH3, CH2, CH3 is there. Students, so you select the path. What you have to do? You select a long chain. Okay, so from right to left as well as left to right, you will get a 5 number of carbon atoms. Root word is pent. Okay, leave that. Now second rule is nothing but a substitution must get a least number. 2 substitutions are there here. Students, if you select a left to right path, then the substitution groups are there at a second, third as well as third. If you give number from right to left, means this direction, then number starts from 3, 3 as well as 2. Which one is correct? This one is correct, one thing. And see here, this is obvious. See, it is not at all related to the alphabetical order. Alphabetical order comes here whenever you have a equivalent. See here, one direction 3, 5, another direction also 3, 5. So at that time you have to go for alphabetical order. Okay. Okay. So now students, this ethyl, okay, you selected. This is not related to the alphabetical, students. It is related to the function, means substituent group. Substituent group must contain least number. So it is 1, this is 2, 3, 4, 5. Then what is the name of the compound? Students, starting now starting name must be first. See here, 2 types of branches are there, CH3 as well as C2H5. So C2H5 means ethyl, CH3 means methyl. So first name, it is to be, which one comes first in the alphabetical, that is to be written first. So therefore 2 ethyl, okay, 2 ethyl. Okay, wait, I will tell. Okay, 2 ethyl over, 2 ethyl over. See here, no need to write 2, 3, 3. I just gave the position here, Sakshi. This is a position. I'm writing the name here. 2 at second position, ethyl group is there, over. Then next to substitution group, you check. Substitution group is nothing but CH3, CH3. How many CH3 groups are there? 2. And that is attached to the same carbon atom. So therefore, write at one carbon atom, one CH3 group is there. Another same, in the same carbon atom, one more CH3 group is there. So if same attachment is there in the same carbon atom, at that time you have to write number twice. 3, 3, put hyphen. What is that group? Methyl. This is also methyl. This is also methyl. It is repeated twice. So what you have to write? Dimethyl. Ethyl, 3, 3 dimethyl. 2 numbers are separated by comma. And what about the root word? Root word is nothing but pent. And you just check the saturation or else unsaturated compound. It is a saturated compound, ANE. So this is the name of the compound. Students, here di-tri, whenever see you write this problem, CH3, write it fast. CH3, CH, CH3, CH, CH3, CH2, CH3. Okay, numbering is to be done from right to left or else left to right. Yes, from left to right, left to right. Why? Because if you give number from right to left, this substituent group will carry 1, 2, 3, 3, 4, 3, 4. Okay, but here now it is 2, 4. Okay, so now what is the name of this? Can you repeat the numbering of H atoms? Numbering of H atoms? H atoms means I don't know that rule. Can you repeat the number of H atoms? Okay, here. CH3, CH3, CH, CH, okay, CH, CH2, CH3. Then here it is CH3, CH3. You just satisfy the carbon valency. It is equal to 4. Now students, first you start with the primary prefix. It is not there. Go for secondary prefix. Yes, two chains are there. See, two groups are there. Okay, at the second position, can I write the name of 2-methyl, 3-methyl? Can I write like that? Okay, you club those two because these two substituent groups are same, right? These two substituent groups are same. So therefore, what you have tried to 2 at a second carbon atom as well as at a third carbon atom, you have a same substitution. So therefore, methyl substitution is there. You use the word di. It is repeated 2 times, right? So it is dimethyl. Okay. So then what about the this chain? Chain is nothing but a pent. And what about the saturation or else unsaturated? It is ANE. Note on the next molecule, students. I'll explain this. CH3, you write it fast. CH3, CH2, C, CH3, CH3, then CH, CH3, CH3. Numbering is to be done from right to left because a substituent group will get a least number at that time. So here all three substituent groups are same. All three are same. So therefore what you have to write now, write the number or position. So starting from the least, you cannot write a 3, 3, 2. First you have to write the least one, that is 2. 2 first, okay. So right to left, yes. 2, 3, 3. At a second carbon atom, 1 CH3 group is there. And at a third carbon atom, 1 CH3. At the same carbon atom, 1 more CH3 group is there. Okay. 2, 3, 3. Put hyphen and write. How many methyl groups are there? 3 methyl groups. So therefore it is trimethyl. Trimethyl. Then continue there only. I don't have space. So let me write what is the chain length. That is nothing but pent. And saturation is nothing but ANE. Students, I'll stop here. I'll stop my class. Otherwise, I can't go to home. Okay, buses are not there, right? So then let me continue in the next class. From next class onwards, you will get full 2 hours. Okay. A quiz is not there today because it is incomplete. I did not complete this nomenclature part. One more rule is pending. But it's actually, I informed about this. That means when substituent groups are there at equivalent position, how to write the name. So I gave example 3, 5, 3, 5 methyl group as well as ethyl group. At that time, you have to go for alphabetical order. Substituent with the substituent, you write the name of the substituent first. Okay. So ethyl, methyl. So at that time means identify the name. At that time, if it comes first, you write that first and then go for methyl. So in detail, we'll study it in next class, students. Okay, you just try for some other molecule, you write it by your own, but balance the carbon valency. It is equal to 4. Varunacharya, you went. Okay, so bye students. Yes.